Now let's move on to question 20. Let f be a function defined by this one. Show that the function f is continuous as s were 0, right? So remember we have a formula. The function f of s is continuous as s were 0. We need limit of the function f of s when s approaches 0 minus equals limit of the function f of s when s approaches 0 plus equals f of 0, right? So keep that in mind. Now we need to do this one step by step, right? So we need limit of the function f of s when s approaches 0 minus, we're gonna pick this guy right here, right? So it could be limit of 1 minus 2 sine s when s approaches 0 minus, right? So substitute 0 for s, it could be 1 minus 0, it could be 1, right? Now limit of the function f of s when s approaches 0 plus, it could be limit of e to the negative 4s when s approaches 0 plus substitute 0 for s, it could be e power of 0, it could be 1, right? Now the last one, f of 0, we're going to use this one right here, right? So it could be 1 minus sine 0, right? Don't forget 2 right here. So it could be 1, right? So we can conclude that since limit of the function f of s when s approaches 0 minus equals limit of the function f of s when s approaches 0 plus equal f of 0. The function f of s is continuous as s were 0. Now question 21. The function f is defined by this one. Let g be the function defined by this guy. Is the function g continuous as s were negative 3? Use the definition of continuity to explain the answer. So again, in order for this one to be continuous, you need limit of the function g of s when s approaches negative 3 minus equals limit of the function g of s when s approaches negative 3 plus equals g of negative 3, right? Now, step number 1, we need to find limit of the function g of s when s approaches negative 3 minus, right? So negative 3 minus, we're going to pick this guy right here, right? So it's going to be the function f of s right here, right? So it could be limit of the function f of s when s approaches negative 3 minus, right? So it's going to be this guy right here, right? So it could be limit of square root of 25 minus s squared when s approaches negative 3 minus, right? Substitute negative 3 for s, the answer is square root of 25 minus 9. It's going to be square root of 16 and it's going to be 4, right? Now, limit of the function g of s when s approaches negative 3 plus. So we're going to pick this guy right here, right? So it could be limit of s plus 7 when s approaches negative 3 plus, and it's going to be substitute negative 3 for s, it could be 4, right? Now we need to check g of negative 3, right? So g of negative 3, we're going to use this one, right? So it could be f of negative 3, right? So it's going to be square root of 25 minus negative 3 squared, right? And it's going to be 4, right? So this condition right here satisfied, right? So then the function is continuous. So you need to say the function g is continuous as equals 3. Now let's move on to question 21. The figure above shows the graph of f prime the derivative of a choice differential function f on the interval negative 3 to 4. The graph of f prime has a horizontal tangent line x equals negative 1, 1, and 3. So it could be right here. The areas of the region bounded by the x-axis, the graph of f prime on the interval negative 2 to 1 and 1, 4, and 9 and 12 respectively. So the area of these regions right here and the regions right here. 9, and 12, right? Question A. Find all x coordinates at which the function f has a relative maximum. Alright, so when it comes to relative extrema increasing, decreasing, think about the first derivative, right? So we need to find the critical numbers first, right? Critical numbers is where f prime of s equals 0, right? So you have critical numbers right here, -2, 1, and 4, right? So we have f prime of s equals 0. Then we have s equals -2, s equals 1, and s equals 4, right? Now, in order to find the relative maximum, we need to create the side charts, right? So remember, if f prime of s changes sign from positive to negative, the function has the relative maximum, right? Or the function f prime of s changes sign from negative to positive, the function fs has the relative minimum, right? The function f prime of s is positive when it's above the axis, right? So we look at this guy above the axis, so it could be positive here, right? This guy is negative, this guy is negative, this guy is negative, and this guy is still negative, right? So only this interval is positive and this interval negative, right? So the function f prime of s changes sign at this point, right? And only this point has the relative maximum, right? So you need to say f of s has a relative maximum at s equals -2 because f prime of s changes sign from positive to negative at s equals -2, right? Now question B. On what open intervals contained in -3 to 4 is the graph of the function f both concave down and decreasing, right? So if the function f is concave down, you have f the program of s must be less than 0, right? And the function f is decreasing, you have f prime of s must be less than 0, right? So it tells us that the function f prime of s must be below the x-axis, right? And at the program of s less than 0, it tells us that the function f prime of s is decreasing, right? Now we need to look for the interval that below the axis, right? So it could be this guy right here, right? And f prime of s is decreasing, which means the slope of the tangent line is less than 0, right? So it could be this guy right here and this guy right here, right? So the answer must be -2 to -1 union 1, 2, 3, right? Question C. Find the x-coordinates of all points of inflection for the graph of f. Alright, now the function f has point of inflection if f prime of s changes from increasing to decreasing or decreasing to increasing. Another way to do this one is we're going to use the second derivative, right? So the function f has points of inflection if f the program of s changes sign from positive to negative or negative to positive, right? So we look at this one right here. This one is the function f prime of s, right? We just draw the tangent line, right? We draw this one right here and this guy right here. And we see that the tangent line is going down, the slope is negative. Tangent line is going up, the slope is positive. Similarly, we draw the tangent lines right here, right? It's going to be negative. Tangent line right here, it's going to be positive, right? So we see that at the program of s changes sign from negative to positive, s equals -1, right? From positive to negative, s equals 1, right? And from negative to positive, s equals 3, right? So we can say that the x-coordinate of all points of inflection for the graph of f at s equals -1, s equals 3. because at the program of s changes sign from negative to positive, right? And s equals 1 because at the program of s changes sign from positive to negative, right? Now let's move on to question 22. Consider a differentiable function f having domain of all positive real numbers, and for which it's known that f prime of s equals 4 times s to the negative 3 for s greater than 0. Question A. Find the s coordinate of the critical point of f, right? So we need to let f prime of s equals 0, right? So it could be 4 minus s times s to the negative 3 equals 0, right? So it's going to be 4 minus s over s cubed equals 0, right? So in order to find the critical number, we need to let the numerator equal 0, right? So we have 4 minus s equals 0, and where the function f prime of s is undefined, right? So which means the denominator must be equal 0, so s cubed equals 0, right? So it's going to be s equals 4 and s equals 0, right? But we look at this one right here, the domain s greater than 0, right? So we don't need this one, right? Now determine whether the point is a relative maximum, minimum, or neither for the function f, right? So we're gonna use the side charts, right? So we put 4 right here, right? So it could be 0 right here and infinity right here. Now we're gonna test the interval, right? So I'm gonna pick 1. Substitute 1 for s into the function f prime of s right here. Right? So it's gonna be positive, right? This guy positive, this guy must be negative, right? So the function is increasing and decreasing. This one is relative maximum, right? So we need to conclude that the function f has a relative maximum at s equals 4 because f prime of s changes sign from positive to negative at s equals 4, right? Now question B. Find all intervals on which the graph of f is concave down, right? It tells us that you need to use the second derivative, right? So we take the second derivative of this one, right? We're going to use the product rule, right? So it will be negative 1 times s to the negative 3, right? Minus 3 times 4 minus s times s power of negative 4, right? So it's going to be negative 1 over s cubed minus 3 times 4 minus s over s to the 4, right? Now we need to rewrite this one in the same denominator, right? So I'm going to multiply the top bottom of this one by s, right? So I have negative s minus, distribute this one could be 12, and it's going to be plus 3s over s power 4, right? Now I'm going to simplify this one, so it could be 2s minus 12 over s power 4, right? We need to find the critical number for this one, right? So at the program of s equals 0 when 2s minus 12 equals 0 and where the function is undefined, right? Which means s equals 0, right? So we solve this one, it's going to be s equals 6 and s equals 0, but the domain is s greater than 0, right? So we just ignore this guy, right? So only have 6, right? So we need to use the side charts, right? So we put 6 over here and it's going to be 0 and positive infinity right here, right? And now I'm going to test the interval, right? So I pick 1. Now I substitute 1 back to this one right here, right? So I get negative number, right? So it should be negative, this one should be positive, right? The function f is concave down. It tells us that f the program must be less than 0, right? So this interval right here has f the program less than 0, right? So we need to conclude that the function f is concave down on the interval 0 to set because f the program of s less than 0, right? Now let's move on to question 23. The figure above shows the graph of f prime, the derivative of f, for s between -7 to 7. The graph of the function f prime has a horizontal tangent line as equal -3, 2, and 5, right? So it could be right here, and right here. And a vertical tangent line as equal 3. So as equal 3, we have the vertical tangent line. Now question A. Find all values of s for s between -7 and 7 at which the function f attains a relative minimum, right? The function f attains a relative minimum when the function f changes from decreasing to increasing, right? Or f prime of s changes sign from negative to positive, right? So we look for the graph right here. This one is f prime of s, right? So anything above the axis should be positive, below the axis should be negative, right? So the inverse changes from negative to positive is to be right here, right? So the relative minimum at s equals -1, right? Question B. Find all values of s for s between -7 to 7 at which the function f attains the relative maximum. Right? We do exactly the same thing, right? So it should be f prime changes sign from positive to negative. Or the function f is increasing and then decreasing, right? So we look at this one from positive to negative. It's going to be right here, right? Positive to negative. So s equals -5, right? So we need to say that the function f attains a relative maximum at s equals -5. Since the function f prime of s changes sign from positive to negative as s equals -5. The last question, find all values of s for s between -7 to 7 at which f the program of s less than 0. Right? It tells us that the function f of s is concave down, right? Either this one or it could be something like this, right? So it means the function f prime of s is decreasing, right? And f the program of s exists. Now we need to find the interval where the function f prime of s is decreasing and f the program of s exists, right? So it's gonna be this interval right here, right? And this interval right here, right? Now we need to exclude s equals 3. Why? Because at this point you have the vertical tangent line of the function f prime of s. It tells us that the function f prime of s is not differentiable at s equals 3. In other words, f the program of 3 is undefined, right? So the answer must be the interval -7 to -3 union 2 to 3 union 3 to 5, right? Because f the program of s exists and f prime of s is decreasing on these intervals. Now let's move on to question 27. Let f be the function satisfying f prime of s equals s square root of f of s for all real numbers s where f of 3 equals 25. We need to calculate the second derivative of f of 3, right? So f the program of s equals use the product rule, right? So it could be square root of f of s, right? Plus we're going to use the formula square root of u prime. It could be u prime over 2 square root of u, right? So it could be f prime of s over 2 square root of f of s times s. Right here I put s in the front, right? So I substitute 3 for s, right? So f double prime of 3 equals square root of f of 3, right? Plus 3 times f prime of 3 over 2 square root of f of 3, right? So f of 3 equals 25. So it could be square root of 25 equals 5 plus 3 times f prime of 3, substitute 3 for s over here. So you have 3 square root of f of 3, right? Over 2 square root of f of 3, right? So it could be 5 plus 9 times square root of 25 equals 5 over 2 times 5, right? 5 and 5 cancel out, so it could be 5 plus 4.5, it could be 9.5, right? Now let's move on to question 28. Consider the curve given by this guy. We need to show that dy over dx equals this, right? So we're going to use the product rule, right? Divided by s equals 1, so we have y squared, right? Plus divided by y squared, it could be 2, and then times s right here, it could be sy dy over ds, right? Minus divided by this one could be 3s squared times y, right? Plus divided by y could be dy over ds, so it could be s cubed dy over ds equals 0, right? Now I'm going to distribute -1, so this guy becomes, so I factor dy over ds out, right? So I have dy over ds, it could be 2sy minus s cubed, right? Equals, I subtract this guy and I'm going to add this guy both sides, right? So I have 3s squared y subtract y squared, right? Divide both sides by this guy, right? So I'm going to end up with the answer right there, right? Now question B. Find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line at each of these points. So you're given x-coordinate is 1, substitute 1 for s over here, you solve for y, right? So we have y squared minus y equals 6. So y squared minus y minus 6 equals 0. Factor this one out, so it can be y minus 3 times y plus 2 equals 0. So y equals 3 and y equals -2. So you have the point, it's going to be 1, 3 and 1, -2, right? Now we need to write an equation for the tangent line at each of these points, right? So we need to write this one first, right? So we have the slope is given by this formula right here, right? So we have dy over ds equals, substitute 1 and 3 for s and y right here, right? So we have 3 times 1 times 3 minus 3 squared over 2 times 1 times 3 minus 1, right? So it could be 9 subtract 9 is going to be 0, right? So the slope equals 0, you have the point slope formula is going to be y minus y1, y1 is 3, equal the slope is 0 times s minus s1, it could be 1, right? So equation should be y equals 3, the first one, right? Now second one right here, you have dy over ds equals s equals 1, so you have 3 times 1, y equals -2 minus -2 squared over 2 times 1 times -2 minus 1, right? So if you simplify this one, it's going to be -10 over -5, it's going to be 2, right? So the equation of the tangent line is going to be y minus y1, it's going to be -2, so plus 2 equals the slope is 2, right? Times s minus s1 right here, right? And if you simplify this one, it's going to be y equals 2s minus 2 subtract 2 minus 4, right? This one is the equation of the second tangent line, right? Now let's move on to question C. Find the x-coordinate of each point on the curve where the tangent line is vertical, right? So remember the Christmas tree. The tangent line is going this way, the slope is positive. Tangent line is going this way, the slope is negative. The tangent line is horizontal, the slope is 0. And tangent line is vertical, the slope is undefined. Alright, so we go back over here, we find the slope is going to be right here. Now the slope is undefined when 2xy minus x cubed equals 0, right? Factor s out, so we have 2y minus s squared equals 0, right? So then s equals 0 or y equals 1/2 s squared, right? I'm going to copy this equation down. Now we substitute 0 for s into this equation to solve for y, right? So it's going to be 0 equals 6. This one impossible, right? So you need to conclude that there is no point with the s coordinate equals 0. Now I'm going to substitute 1/2 s squared for y into this equation. I have s times 1/2 s squared all together square minus s cubed times 1/2 s squared equals 6, right? So it's going to be 1 over 4 s to the 5th minus 1 over 2 s to the 5th equals 6, right? So it's going to be negative 1 over 4 s to the 5th equals 6. Multiply both sides by negative 4, so s to the 5th equals negative 24. Take 5th root both sides, so s equals 5th root of negative 24, right? This one is the final answer. Now let's move on to question 29. Grass clippings placed in a bin where they decompose for t between 0 and 30. The amount of grass clippings remaining in the bins is modeled by this equation, where A of t is measured in pounds and t is measured in days. Find the average rate of change of A of t over the interval 0 to 30. Alright, so remember we have the average rate of change formula is given by the formula f of b minus f of a over b minus a, right? So a equals 0, b equals 30, right? So you have a of 30 subtract a of 0 over 30 subtract 0, right? So you have a of 30 is going to be 6.687 times 0.931 raised to the 30. Subtract 6.687. 0.931 raised to the 0 is going to be 1, right? So I just leave it like that. Over 30, right? So we can print up the calculator. Now you're going to hit the button right here, put the fraction, right? So it could be 6.687, control enter. It's going to be negative 0.1968, right? Now question B. Find the value of a prime of 15. Use the correct units. Interpret the meaning of the value in the context of the problem. Alright, so we have a prime of 15 equals. We're going to print up the calculator. Now, you need to store the function, right? So, you just press A of t, then press Ctrl and the button right here. It's going to be 6.687 times 0.931 raised to the t, and then press enter. Alright, now you need to evaluate derivative of this one at t equal 15, right? So you're gonna press menu calculus derivative at a point right here, right? This one I just change it to t, right? And value right here should be 15, right? And then press OK right here, right? So I'm gonna put the function right here, a of t, right? And then press Control Enter. It's gonna be 0.163, right? This value tells us that the amount of grass clippings in the bin is decreasing because you have the negative side right here, right? At a rate of 0.164, right? Pounds per day at time t equal 15 days. Now let's move on to question 30. The temperatures of water in the tub at time t is modeled by a strictly increasing choice differentiable function W, where Wt is measured in degree Fahrenheit, T is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees. The water is heated for 30 minutes, beginning at time t equals 0. Values of Wt at selected times t for the first 20 minutes given in the table above. Question A. Use the data in the table to estimate W prime of 12. Show the computation that leads to your answer using the correct units. Interpret the meaning of your answer in the context of this problem. Alright. So W prime of 12 equals 12 is between 9 and 15, right? So we're going to use the mean value theorem, right? So it could be W of 15 subtract W of 9, right? Over 15 subtract 9. Now W of 15 is going to be 67.9 subtract 61.8 divided by 15 subtract 9, right? Now we're going to print up the calculator. So we're going to hit the button right here, pick the fraction, and then press Control Enter. It's going to be 1.0167, right? Now we need to say that the water temperature is increasing because this one is the plus side, right? At a rate of approximately 1.167 degree per minute at time t equals 12 minutes. Now let's move on to question 31. Alright, so question 31 is similar to question 30. Alright, now you given 12 right here, right? So the question wants you to calculate W prime of 12. You're going to use the mean value theorem, right? So W prime of 12 equals W of 15 subtract W of 9 over 15 subtract 9, right? So the answer must be negative 0.5 degrees per day, right? Now you have two different ways to do this one. Since 12 is given, you can pick this interval right here, right? So W prime of 12 is approximately W of 12 subtract W of 9, right? Over 12 minus 9. You have another way to do this one is you're going to pick this interval right here, right? So W prime of 12 equals W of 15 subtract W of 12 over 15 subtract 12, right? Now question 32. Solution to the differentiable equation dy over dx equals s squared cubed also satisfy this guy. Let y equals f of s be a particular solution to the differentiable equation. Dy over ds equals s squared cubed with f of 1 equals 2. Write an equation for the line tangent to the graph y equals fs at s equals 1. Alright. Now you need to find the slope of the equation of the tangent line first, right? So we have dy over ds hat s equals 1, y equals 2, right? So point 1, comma 2 equals using this one right here, right? So we have 1 times 2 cube equals 8, right? Now you have the other pair right here. This is s equals 1, y equals 2. So we're going to use the point slope from formula, right? So we have y equals the slope 8 times s minus s1, which means 1 right here, at y1, which is 2 right here, right? Now question B. Use the tangent lines equation from part A to approximate f of 1.1. Right, so I just name this one as f of s equals 8 times s minus 1 plus 2. Right, so have f of 1.1 equals 8 times 1.1 subtract 1 plus 2. Right, so it could be 8 times 0.1 plus 2, right? So it could be 0.8 plus 2 equals 2.8, right? Given that f of s greater than 0 for s between 1 and 1.1 is the approximation for f of 1.1 greater than or less than f of 1.1. Alright, so since f of s greater than 0, right? And you have the second derivative right here. D square y over ds square equals, using this point right here, s equals 1, y equals 2, substitute over there, right? So you have 8 times 1 plus 3 times 1 times 2 square equals 4, right? So it could be positive, right? So it tells us that the function is concave up, right? You look at the notes right here. The function concave up, the approximation right here is underestimate. It tells us that the tangent line is under the curve, right? We look at the notes right here. Tangent line is under the curve, which means it's gonna underestimate the value, right? Question 33. Ship A traveling due west toward Lighthouse Rock at a speed of 15 kilometers per hour. Ship B is traveling due north away from Lighthouse Rock at a speed of 10 kilometers per hour. Let S be the distance between ship A and Lighthouse Rock at time t, and let Y be the distance between ship B and Lighthouse Rock at time t, as shown in the figure above. Now, question B. Find the rate of change in kilometers per hour of the distance between the two ships when S equals 4 kilometers and Y equals 3 kilometers, right? So we need to find this guy right here, right? Now I name this one R, right? So I have R square equals S square plus Y square by Pythagorean theorem, right? So I substitute S equals 4, Y equals 3, right? So R square equals 4 square plus 3 square, it could be 16 plus 9, it could be 25. So R equals square root 25, it could be 5, right? Now, I'm going to use this equation right here. I'm going to take derivative both sides with respect to t, right? So I have 2r dr over dt, right? Equals 2s ds over dt plus 2y dy over dt, right? Divide both sides by 2. So I have r times dr over dt equals s ds over dt plus y dy over dt, right? Now r equals 5, so I put 5 right here, right? Dr over dt, this is what I need to find, right? Because the question wants us to find the rate of change of the distance between two ships, right? So two ships is could be r, right? S equals 4 times ds over dt. ds over dt is given by 15 right here, but you need to be careful. It's gonna be negative, right? Now think about the x and y coordinate right here. This is west, this is east, north, and south, right? Look at the x and y coordinate right here. It's gonna be positive, negative, negative, positive, right? So since ship A traveling due west, right? So traveling this way, it could be negative, right? So it could be negative 15 plus y equals 3. And ship B traveling due north away from lighthouse, so it's traveling this way, right? So it could be positive, right? So it could be 10 right here. So dr over dt equals 4 times negative 15, it could be negative 60 plus 30 divided by 5, right? So it could be negative 6 kilometers per hour, right? Now let's move on to question C. Let theta be the angle shown in the figure, so theta right here. Find the rate of change of angle theta in radians per hour when x equals 4 and y equals 3 kilometers, right? So I don't have enough space, I'm gonna write over here, okay? So I have tangent theta equals opposite over adjacent, which is y divided by s, right? Now I'm gonna take derivative both sides with respect to t, right? So derivative of this one turns out to be secant square theta, right? D theta over dt, right? Equals, I'm gonna use the quotient rule for this one, right? So it's gonna be derivative of y is going to be dy over dt, right? So multiply by s, it could be s dy over dt. Subtract derivative of s, it could be ds over dt, right? So multiply by y, it could be y ds over dt divided by s squared, right? Now previously we calculate r right here equals 5, right? Now we need to find secant of theta. So secant of theta is actually 1 over cosine theta, right? So it's going to be 1 over cosine theta equals adjacent over hypotenuse, right? So it could be 4 over 5. So I'm going to check reciprocal of this one. It could be 5 over 4, right? I have secant square of theta. It could be 5 over 4 square. It could be 25 over 16 d theta over dt, right? Equals s equals 4 right here. dy over dt, 10 right here, right? Minus y equals 3 right here. Times ds over dt, it could be negative 15, right? Over s squared. It could be 4 square, it could be 16, right? It could be 85 over 16, right? So d theta over dt equals 85 over 16 times 16 over 25, right? This guy cancel out, right? So divide the top bottom by 5, it could be 17 over 5. And the unit is radian per hour, right? Now let's move on to question 34. The function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Question D. The function p is defined by p of s equals f of s squared minus s. Find the slope of the line tangent to the graph of p at the point where s equals -1. Alright, so we need to take the derivative of this one, right? So we have p prime of s equals, right, f prime of s squared minus s, and don't forget to take the derivative of the inner function right here, right? So it can be 2s minus 1, right? Now substitute -1 for s, so we have p prime of -1 equals f prime of -1 square, it could be 1. Negative of -1 is could be 1, so it could be 2, right? Times 2 times -1, it could be -2 minus 1 could be -3, right? Now f prime of 2, look at this one right here. F prime of 2 is right here. So f prime, which means the slope of this tangent line, right? So we're going to use right over run right here. So right equals 1, 2, 3, 4, and run equal 2, right? So actually it could be negative, right? Because the graph going down, right? So it could be negative 4 over 2 times negative 3, right? So it could be 6, right? Now question 35. A 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t measured in liters per hour, where R is given by the piecewise defined function. Now question C. Find R prime of 3 using the correct units. Explain the meaning of that value in the context of this problem. Now 3 right here is between this interval right here, so we're gonna pick this one, right? So we have R prime of t equals, we're gonna use the quotient rule, right? So it could be 600 times t plus 3, right? Minus derivative of t plus 3, it could be 1, right? Times 600 t over t plus 3 square, right? So we're going to simplify this one, 600 times t, and this one cancel out. So we have 1800 over t plus 3 all together square, right? So we have R prime of 3 equals 1800 divided by 3 plus 3 equals 6 square equals 36, right? So 1800 divided by 36 it could be 50, right? Now we need to explain the meaning of this value in the context of the problem, right? Since this function is the rate, right? So we need to say the rate at which water is draining out of the tank at t equals 3 hours is increasing, right? Because we have the plus side right here, at 50 liters per hour square, right? Because the unit right here is liters per hour, right? So when you take the derivative of this one, it could be liters per hour, right? So keep that in mind. Now let's move on to question 36. Let f be a twice differentiable function defined on the interval -1.2 to 3.2 with f of 1 equals 2. The graph of f prime derivative of f is shown below. The graph of f prime crosses the x-axis as x equals -1 and 3. Has a horizontal tangent line as x equals 2. Let g be the function given by g of s equals e to the f of s. Question A. Write an equation for the line tangent to the graph of g as s equals 1, right? So first we need to find the first derivative, right? So we have g prime of s equals f prime of s times e to the f of s, right? Now s equals 1, so we have g prime of 1 equals f prime of 1 times e to the f of 1, right? So we substitute value f prime of 1 equals -4 right here, right? So -4 times e to the f of 1. f of 1 equals 2 right here, right? We have y minus y1 equals m times s minus s1, right? So y equals, the slope is -4 e squared times s minus s1. s1 is 1 right here. And then plus y1. y1 is right here. So we have g of 1 equals e to the f of 1, right? But f of 1 equals 2 right here, so it could be e squared, right? So we have e squared right here. Now let's move on to the last question. The function h is defined by this one. Find h prime of 0. If it does not exist, explain why. Now first you need to take the derivative of this function, right? So we have h prime of s equals 4s cubed plus 3 for s less than or equal to 0. And 3 e to the 3s for s greater than 0. Now we need to find the limit of the function h prime of s when s approaches 0 minus, we're going to pick this guy right here, right? So it could be limit of for s cubed plus 3 when s approaches 0 minus, right? So it could be substitute 0 for s, the answer is 3, right? Now limit of h prime of s when s approaches 0 plus, we're going to pick this guy right here, right? So it could be limit of 3e to the 3s when s approaches 0 plus substitute 0 for s, it could be 3, right? Now this guy equal this guy, so you may conclude that h prime of 0 equals 3, but it's not the case. Why? Because you need to check to see if the function is continuous as x equals 0, right? Remember, if the function is not continuous, the function is not differentiable, right? So we need to check limit of the function h of s when s approaches 0 minus, right? We're going to pick this guy right here. So we have limit of s to the 4 plus 3s when s approaches 0 minus, substitute 0 for s, right? So it could be 0. Now limit of h of s when s approaches 0 plus equals limit of e to the 3s plus 5 when s approaches 0 plus, right? Equals substitute 0 for s, it could be 1 plus 5 equals 6. Now this guy and this guy are not the same. So we say that the limit of h of s when s approaches 0 does not exist, right? So it tells us that the function is discontinuous as s equals 0. Therefore, the function h of s is not differentiable as s equals 0. So then this one does not exist, right? Now let's move on to question 13. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at a time t between 0 and 6, given by a differentiable function c, where t is measured in minutes. Select the values of CLT measured in ounce, given in the table above. Is there a time t between 2 and 4 at which C-prime of t equals 2? Alright, so we're going to apply the mean value theorem, right? Now, before we're going to apply the mean value theorem, make sure the function is continuous and differentiable on the interval, right? So, look at the information given right here. The function c is differentiable, right? So, if the function differentiable, it implies that the function is continuous on the closed interval, right? Now, we're going to check within this interval, right? So we have c of 4 subtract c of 2 over 4 minus 2, right? So c of 4 is right here, 12.8. And c of 2 is right here, 8.8 divided by 4 minus 2. And this could be 4 divided by 2, it could be 2. This value is exactly this value, right? So we're going to say yes by the mean value theorem. There is at least a number t between 2 and 4 for which c prime of t equals 2, right? Now let's move on to question 14. Train A runs back and forth on an express section of railroad track. Train A's velocity is measured in meters per minute, given by a differentiable function v sub a of t, where time t is measured in minutes. Select the values for v sub a of t given in the table above. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t between 5 and 8. Alright, so we're going to apply the IVT. So in order to apply the IVT, the function must be continuous, right? So since the function is differentiable right here, it implies the function is continuous, right? Now we look for the interval 5 to 8, right? So 5 right here and 8 right here, right? So there is number t between 5 to 8 such that negative 100 right here between negative 120 and 40, right? Now let's move on to question 15. A continuous function f is defined on the closed interval negative 4 to 6. The graph of f consists of a line segment and a curve that is tangent to the x-axis at x equals 3, right here, as shown in the figure above. On the interval 0 to 6, the function f is tridifferentiable with f the program of s greater than 0. Question C. Is there a value of a such that a between negative 4 and 6 for which the mean value theorem applied to the interval a to 6 guarantees a value c for c between a to 6 at which f prime of c equals 1 over 3. Now we're going to apply the mean value theorem, right? So we have f prime of c right here equals 1 over 3, right? And this guy actually f of b minus f of a over b minus a, right? Now a equals a and b equals 6, right? So we have f of 6 minus f of a over 6 minus a, right? So f of 6 is going to be 1 right here. F of a, we don't know it, we just leave it right here, right? Over 6 minus a, right? Now we need this guy right here to be 1/3, right? So we can check the value within this interval right here, right? So I'm going to check a equals 3 first, right? So I substitute over here, I have 1 minus f of 3 equals 0 right here, right? Subtract 0 over 6 minus 3, and it's going to be 1/3. So this one is exactly this one, right? So we can conclude that a equals 3, right? Now let's move on to question 16. Let g be a continuous function with g of 2 equals 5. The graph of the b-square linear function g prime. The derivative of g is shown in the figure above for s between negative 3 to 7. Question D. Find the average rate of change of the function g prime of s on the interval negative 3 to 7. Does the mean value theorem apply on the interval negative 3 to 7? Guarantee a value of c for c between negative 3 to 7 such that g the program of c is equal to the average rate of change. Why or why not? Now we need to find the average rate of change of the function g prime of s on the interval negative 3 to 7, right? So we have g prime of 7 subtract g prime of negative 3 over 7 subtract negative 3, right? So g prime of 7 is going to be 1 right here. Subtract g prime of negative 3 is going to be negative 4 right here. Over 10, and it's going to be 1/2, right? Now, does the mean value theorem apply on this interval? Guarantee a value of c for c between negative 3 to 7 such that g the program of c is equal to this average rate of change. We're going to say no, right? Because in order to apply the mean value theorem, the function must be differentiable on that interval, right? But look at this one right here. We see that the function has a sharp turn right here, sharp turns right here, sharp turn right here. So the function is not differentiable on those values, right? So we need to say the mean value theorem does not guarantee the existing value of a value of c with the stated properties because g prime is not differentiable for at least one point on this interval, right? Now let's move on to question 17. The function f and g is differentiable for all real numbers and g is strictly increasing. The table above gives values of the functions and their first derivative as selected values s. The function h is given by h of s equals f of g of s minus 6. Question A. Explain why there must be a value r for r between 1 and 3 such that h of r equals negative 5. Alright. So first we need to calculate h of 1, right, equals f of g of 1 minus 6, right? So cái be f of g of 1 is 2 right here, right? So f of 2 minus 6, f of 2 is 9 right here. 9 minus 6 equals 3, right? Now h of 3 is going to be f of g of 3 minus 6. So g of 3 is going to be 4 right here. So f of 4 minus 6. f of 4 is going to be negative 1. Negative 1 minus 6 could be negative 7, right? So in order to answer this question, we need to use the IVT, right? So we look at the output right here, negative 5 right here is between negative 7 and 3, right? And the input right here is between 1 and 3 right here, right? Which is this guy, right? So we're going to say that since the function f and g are differentiable, right? It implies that the function f and g are continuous, right? Then the function h is continuous, right? So by the IVT, there exists a number r between 1 and 3 such that h of r equals negative 5, right? Now let's move on to question B. Explain why there must be a value of c for c between 1 to 3 such that h prime of c equals negative 5. Alright, so we're going to use the MVT, right? We need to calculate h of 3 minus h of 1 over 3 minus 1, right? So h of 3 equals negative 7 right here. Minus h of 1 equals 3 right here. Over 3 minus 1 equals 2. So it could be negative 10 over 2 equals negative 5, which is equals h prime of c, right? So we need to say that since the function h is continuous and differentiable, the mean value theorem applies, right? So by the mean value theorem, there exists a value of c between 1 and 3 such that h prime of c equals negative 5, right? Let's move on to question 18. Let f be a tri-differentiable function such that f of 2 equals 5, f of 5 equals 2. Let g be the function given by g of s equals f of s. Question A. Explain why there must be a value of c for c between 2 to 5 such that f prime of c equals negative 1. Alright, so this one implies the mean value theorem, right? So we need to calculate f prime of c is going to be f of 5 minus f of 2 over 5 minus 2, right here. F of 5 equals 2 right here. F of 2 equals 5 minus 5 over 3, right? So it could be negative 1, which is equal to this one right here, right? So you need to say that since the function f is continuous and differentiable, the mean value theorem applies, right? So by the mean value theorems, there exists a number c between 2 and 5 such that f prime of c equals negative 1, right? Now question B. Show that g prime of 2 equals g prime of 5. Use this result to explain why there must be a value of k for k between 2 and 5 such that g double prime of k equals 0, right? This one implies the Rolle's theorem, right? Alright, so we need to find g prime of s first, right? Check the derivative of this one using the chain rule, right? So it could be f prime of s times f prime of f of s, right? Now we need to calculate g prime of 2 and g prime of 5 to see what happens, right? So we have g prime of 2 equals f prime of 2 times f prime of f of 2, right? So it could be f prime of 2 times f of 2 equals 5 right here, right? So cái bị times f prime of 5. Now g prime of 5 equals f prime of 5 times f prime of f of 5, right? F of 5 right here equal 2, right? So we have f prime of 2 times f prime of 5, right? So we can conclude that g prime of 2 equals g prime of 5, right? Now to answer this question right here using the Rolle's theorem, we need to say that the function f is twice differentiable, then the function g prime is differentiable everywhere. So the mean value theorem applies. So by the mean value theorem, there exists a number k between 2 and 5 such that g double prime of k equals g prime of 5 subtract g prime of 2 over 5 minus 2, and this guy actually 0 because this guy and this guy the same, right? Now let's move on to question D. Let h of s equals f of s minus s. Explain why there must be a value of r between 2 and 5 such that h of r equals 0. Alright, so we're going to use the IVT, right? So we need to calculate h of 2. It's going to be f of 2 minus 2, right? F of 2, we're going to use the value right here. It's going to be 5, right? So it's going to be 5 minus 2 equals 3. Now h of 5 equals f of 5 minus 5, right? F of 5 equals 2, right here, right? So it's going to be 2 minus 5 equals negative 3, right? Now look at this one right here, h of r equals 0, right? 0 is the output. This one falls into the interval negative 3 to 3, right? And r right here is the input, fall into this interval 2 to 5, right? So the IVT applies because the function h of s is continuous, right? So we need to say that since the function h of s is continuous and h of r equals 0 is greater than negative 3 less than 3, then by the IVT there must be a number r between 2 and 5 such that h of r equals 0. Question 24. The twice differentiable functions f and g are defined for all real numbers as value of the function f, f prime, g, g prime for various values of s given in the table above. Question D. Evaluate this one, right? So observe that if you have the function f of g of s, and then if you take the derivative of this one, it turns out to be g prime of s times f of g of s, right? This one is the chain rule, right? So if you take antiderivative of this one, and then it becomes f of g of s, right? So this one becomes f of g of s evaluated from negative 2 to 3, right? So you have f of g of 3 subtract f of g of negative 2, right? Now g of 3, we look at this one right here, g of s right here, and 3 is right here, it's going to be 1, so it could be f of 1. Subtract f of g of negative 2, negative 2 is right here, it's going to be negative 1, right? Now f of 1 is 2, f of negative 1 is 8, so it could be negative 6. Now question E. The antiderivative of f prime of s is going to be f of s, right? So it could be 2 f of s, right? Evaluated from negative 2 to negative 1, right? Plus antiderivative of this one could be 3s evaluated from negative 2 to negative 1, right? So it could be 2 f of negative 1 subtract f of negative 2, right? Plus 3 times -1 subtract -2, right? So f of -1 equals 8, right? So it could be 2 times 8 minus f of -2 is going to be 12 right here, plus 3 times -1 plus 2 is going to be 1. So it could be 8 minus 12 to be -4 times 2 -8 plus 3 is to be -5, right? Now let's move on to question 25. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at the gravel processing plant is multiplied by T of t equals 90 plus 45 cosine t squared over 18, right? So this one is coming where t is measured in hours and t between 0 and 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel, right? So this one is the initial amount. During the hours of operation, t between 0 and 8, the plant processes gravel at a constant rate of 100 tons per hour, right? So this one already processed. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday, right? So basically, you just calculate the interval from 0 to 8 of this function right here, right? Alright, so you're gonna bring up the calculator, hit the button right here, and then pick this guy right here. The interval from 0 to 8 of 90 plus 45 times cosine of, hit the button right here, pick the fraction, t squared over 18, and then dt right here, right? And then press Ctrl Enter. It's going to be 825.551. Now question D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday, right? So we start from 500, right? And this one is incoming, right? And then we already process this one, right? So basically, you just name this one as U of t equals, this is where you start 500, right? And then the comment right here, which is the function right here, right? Interval from 0 to t, g of s, and then you need to subtract 100 right here, right? ds. Now, to find the maximum amount, we need to use the candidate test, right? So we need to take the derivative of this one. U prime of t equals derivative of this one equals 0, right? Derivative of this one is going to be g of t, right? And then minus 100. And we're going to let this one equal to 0, right? So U prime of t equal to 0 to find the critical number, right? So it could be g of t equals 100, right? Now we need to solve for t, right? You know that t between 0 to 8 only, right here, right? So we're going to bring up the calculator. The first way, you just grab the function g of t and the line y equals 100, and then you just find the intersection. Alright, the second way, we're going to use the numerical solver. Alright, so I'm going to use the second way to do this one. Right? So I'm going to press menu, go to algebra, and number 6 right here. Alright, now I just input the equation right here, g of t equals 100, right? And then don't forget to define the variable s right here, and then press Ctrl Enter. The answer is 4.923, right? Now we're going to use the candidate test, so we're going to sketch the table as follows. Alright, at the beginning When t equals 0, we have 500, right? Which is this guy right here. Now, t equals 4.923, right? So we're going to print up the calculator. We're going to substitute this value right here into the equation u of t right here. 500 plus the interval. We're going to hit the button right here. Pick the interval right here. Right? 0, 2. This number, I just copy this one over here. So that I'm going to have the more accurate value, right? Then subtract 100. Then put the S right here, right? And then press Control Enter. It's gonna give you 635.376, right? Now when t equals 8, I do exactly the same thing, right? So I just copy this one down. Replace 4.923 with 8. And then press Control Enter. It's gonna give you 525.551. Finally, the maximum value is right here. Now let's move on to question 26. Find the average value of this function, right? So we have the average value is given by the formula 1 over this is a, this is b, right? b minus a, which means 2 minus 0. The interval from 0 to 2, right? Of the function fs, which is 4 cosine of pi over 4 times s, right? ds. Now, 4 and 2 right here cancel out, right? So we have 2 interval from 0 to 2 cosine of pi over 4 s ds, right? Now, we need to take anti-derivative of this one. So remember, we have the formula cosine of as plus b ds. It's going to be 1 over a sine of as plus b plus c. So keep that in mind. Now you're going to take reciprocal of pi over 4. It's going to be 4 over pi. 4 over pi times 2. It's going to be 8 over pi. Right? And then it's going to be sine of pi over 4s. Right? Evaluated from 0 to 2. So we're going to substitute 2 for s. It's going to be 8 over pi times sine of pi over 2, right? Substitute 0 for s, it will be minus sine of 0, right? Now sine of 0 equals 0, sine of pi over 2 equals 1. So the answer is 8 over pi, right? Now let's move on to question 27. A tank contains 125 gallons of heating oil at time t equals 0. During the time interval 0 to 12 hours. Heating oil is pumped into the tank at the rate h of t equals this 1 gallons per hour. During the same time interval, heating oil is removed from the tank at the rate right here. Question A. How many gallons of heating oil are pumped into the tank during the time interval 0 to 12 hours? Alright, so basically we need to find the interval from 0 to 12 of this function, right? So it will be interval from 0 to 12 of. So we're gonna print up the calculator. Alright, so I'm gonna copy this one down over here. Right, I just change the upper bound and lower bound. It's gonna be 0 to 12 ds. And then press Control Enter. It's gonna give you 70.5708. Now let's move on to question C. How many gallons of heating oil are in the tank at the time t equals 12 hours? Alright, so remember you start from 125 gallons, right? So you have 125, right? Plus rate inch is right here, right? So it will be h of t, and then rate out is right here. You need to subtract r of t, right? And then you need to take the interval from 0 to 12, right? And then dt right here. So we're gonna print up the calculator. I'm going to copy this one over here. H of t subtract of t, right? So and then we're going to add 125, right? And then press Control Enter. It's going to be 122.026, right? Now let's move on to question D. Ask what time t for t between 0 to 12 is the volume of heating oil in the tank the least, which means the absolute minimum, right? Alright, so I'm gonna let A of t equals this guy right here, right? 125 plus the interval from 0 to t. H of s minus R of s ds, right? Alright, now we need to find the critical numbers, right? So we're going to take A prime of t is going to be H of t minus R of t, right? We need to let this one equal to 0 to find the critical numbers, right? So basically, you just grab these two functions on the same graph, and then you're going to find the intersection, right? You're going to input the first function, which is h of t, right? And then press enter. You get this one right here. Now remember the domain from 0 to 12. So you need to restrict the domain, hit menu, window zoom, window setting right here. It should be from 0 to 12. And then press enter. Alright. Now for the second equation, you're going to hit tab right here. Input the second equation, which is 12 sine t squared over 47, right? Then press enter. You get this one right here. Alright, now you need to find two intersections right here. So you need to hit menu, analyze graph, number 4, go to the left, go to the right, the first intersection right here. You do exactly the same thing for the second one. The second one right here, right? So you have 4.79 and 11.3, right? Now we're going to use the candidate test, so we're going to scan the table. Now at t equals 0, substitute 0 for t over here. So right here you get 125, right? Now at t equals 4.79, you have 125 plus interval from 0 to 4.79. So we're going to bring up the calculator. Now to do this one quickly, I just store the function h of s and r of s. So I'm going to press h of s and then press Control and put it right here, and then I'm going to input h of s equals this guy right here, and then press enter. Alright, now I'm going to store the second equation, so I'm going to name r of s and then press enter. Alright, now you just hit 125 plus the button right here, put the interval from 0 to 4.79 of, and then press Control enter. You get 149.407. Now at t equals 11.3, you do exactly the same thing, right? So I just copy this one down over here. I just change the upper bound right here, 11.3, right? And then press Control enter. It's gonna be 120.739, right? And last one is gonna be 125 plus interval from 0 to 12, h of s minus r of s ds, right? I just copy this one down over here. I just change the upper bound 12, right? Press Control enter. It's going to be 122.0257. Alright, so the smallest value is 120.739, right? When t equals 11.3. This one is the least volume at t equals 11.3, right? Now let's move on to question 28. Find the time t for which the amount of grass clippings in the bins is equal to the average amount of grass clippings in the bin over the interval 0 to 30, right? So this is the average values, right? So you have A of t equals 1 over 30 subtract 0. It's going to be 30. Then row from 0 to 30 of A of t dt, right? And we need to solve for t, right? So we're going to print up the calculator. Hit add calculator. First, I need to store the function a of t, right? So I need to hit a parenthesis t, press Ctrl and the button right here. 6.687 times 0.931 raised to the t, and then press enter. Alright, now we need to find the interval from 0 to 30 of a of t dt and divide by 30, right? And then press Ctrl enter. It's going to be this number. Alright, now I'm going to press menu, algebra, and number 6 right here, numerical solve. Alright, now I need to put the function a of t equals this number right here. So I copy this number down. I put it over here. And then put the comma. Define the variable. The variable right here is t. And then press Ctrl enter. It's gonna give you the values 12.414. Now let's move on to question 29. The function f is defined by f of s equals square root of 25 minus s squared for s between -5 and 5. Find the value of this interval, right? So basically, you're going to use u substitution, right? So I'm going to let u equals square root of 25 minus s squared, right? So I'm going to square both sides. So it can be u squared equals 25 minus s squared, right? Check the derivative both sides with respect to s, right? So it could be 2u du equals -2s ds, right? Now we look at this one, we see that s ds right here, right? So divide both sides by -2, right? So it's gonna be s ds equals -u du, right? Now I need to change the upper bound and lower bound, right? So original one, s equals 0, s equals 5. The new one, u equals, substitute 0 for s over here, it's gonna be 5, right? Substitute 5 for s over here, it's gonna be 0, right? So I have this guy right here becomes the interval from 5 to 0 of u, this one, right? And s ds becomes -u du, right? So it can be u squared du, and I put negative side right here, right? Now I change the negative side into positive side, and then I need to flip the bounds right here, right? So it will be interval from 0 to 5 u squared du, right? So it's going to be 1 over 3 u cubed. Evaluate from 0 to 5, right? So it could be 1 over 3 times, substitute 5 for u, right? So it could be 5 cubed, subtract 0 cubed, right? So it could be 1 over 3 times 125, right? Or 125 over 3. Now question 30. There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move on to a ride at a rate of 800 people per hour. The graph above shows the rate R of t at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. Question A. How many people arrive at the ride between t equals 0 and t equals 3. Alright, so 0 right here and 3 is right here. Basically, you just calculate the error under the curve, right? So we need to calculate the error of this shape right here. And this guy actually the two trapezoid, right? The first trapezoid is right here, right? So the integral from 0 to 3 of r of t dt equals base 1 is going to be 1000, right? Plus base 2 is going to be 1200, right? Times the height right here is 2 divided by 2, right? Plus the second one, base 1 is 1200 plus base 2 is 800 times the height is 1 divided by 2, right? Now 2 and 2 cancel out, so this guy becomes 2200, right? Now this guy 1200 plus 800 is going to be 2000, right? 2000 divided by 2 is going to be 1000. And the answer should be 3200 people. Now question D. Write but do not solve an equation involving an integral expression of R whose solutions gives the earliest time t at which there is no longer a line for the right. Now we know that initial people plus arrivals equals people served. Right, so initial people right here 700, right? Plus arrival is going to be in terms of the function of t right here, right? So it's going to be integral from 0 to t. Now r of, I'm going to put the another variable s, right? ds equals 800 people per hour, right? So it should be 800 times t, right? T is the number of hours, right? Now let's move on to question 31. The rate of fuel consumption in gallons per minute recorded during an airplane flight is given by a twice differentiable and strictly increasing function r of time t. The graph of r and a table of selected values of r t for the time interval t between 0 and 90 minutes shown above. Question D. For b between 0 and 90 minutes, explain the meaning of the interval from 0 to b of r of t dt in terms of fuel consumption for the plane. So you know that R of t represents the rate of fuel consumption. So when you take the integral from 0 to b of R of t dt, this guy is the total amount of fuel in gallons consumed for the first b minutes. Explain the meaning of 1 over b times the integral from 0 to b of R of t dt in terms of fuel consumption for the plane. Alright, so we need to say that 1 over b times the integral from 0 to b of r of t dt. Actually, 1 over b minus 0, right? Integral from 0 to b of r of t dt, right? So this one is the average value of the rate of fuel consumption in gallons per minute during the first b minutes. Now question E. Using correct units of measure, explain the meaning of r of 90 minus r of 0 over 90 minus 0 in the context of the problem. This guy actually f of b minus f of a over b minus a. And this guy actually average rate of change formula, right? So we need to say this guy right here is the average rate of change of the rate of fuel consumption in gallon per minute square over the time interval 0 to 90 minutes. Now let's move on to question 32. Let f be a continuous function defined by fs equals this one. Find the average value of the function f on the interval -1 to 1. Alright, so this is a and this is b. Now remember, you have the formula for the average value function is given by 1 over b minus a, the interval from a to b of f of s ds, right? So this guy turns out to be 1 over 1 minus -1, interval from -1 to 1 of f of s ds, right? So it can be 1 over 2, interval from -1 to 1 of f of s ds, right? So we need to calculate the interval from -1 to 1 of f of s ds, right? So we look at this one, we have the midpoint right here, 0, right? So the interval from -1 to 1 of f of s ds can be written as the interval from -1 to 0 of f of s ds plus the interval from 0 to 1 of f of s ds, right? So interval from -1 to 0, we're gonna use this function right here, right? So it can be interval from -1 to 0 of 1 minus 2 sine s ds, right? And interval from 0 to 1, we're going to use the second one right here, plus interval from 0 to 1 of e to the -4s ds, right? So we're going to take antiderivative of 1, it's going to be s, right? Antiderivative of sine s, it's going to be negative cosine s, right? So it becomes plus 2 cosine s, right? Evaluated from -1 to 0, right? Plus the antiderivative of this one is going to be -1 over 4 e to the -4s, evaluated from 0 to 1. Remember, the antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c. Alright, so keep that in mind. Alright, substitute 0 for s is going to be 2 because cosine 0 equals 1, right? Now substitute -1 for s, so it could be subtract parentheses -1 plus 2 cosine of -1, right? Now for this one, substitute 1 for s, you have -1 over 4 e to the -4, right? And substitute 0 for s, so subtract up this one, which means plus 1 over 4 e power of 0 is going to be 1, right? Now we're going to simplify this one, it's going to be 3, right? Plus 1 over 4 is going to be 13 over 4, right? Plus 2 cosine of -1, right? Minus 1 over 4 e to the -4, right? Now we need to calculate this one right here, right? The average value. So take 1/2 of this one, it's going to be 13 over 8, right? Plus cosine of -1 minus 1 over 8 e to the -4. This one is the final answer. Now let's move on to question 15. A particle moves along the straight line for t between 0 and 5. The velocity of the particle is given by this function, and the position of the particle is given by s of t. It's known that s of 0 equals 10. Question A. Find all values of t in the interval 2 to 4, for which the speed of the particles is 2, right? So we know that the speed of the particle, which means absolute value of v of t equals 2, right? For t between 2 to 4, right? We have absolute value of -2 plus t squared plus 3t raised to the 6 over 5 minus t cubed equals 2, right? So this one is the calculator active problems, right? So we're gonna print up the calculator. Add graphs. Now, the first function f1 of s, you're gonna input this guy right here, the left hand side, right? So you're gonna input the absolute value side first, right? Hit the button right here, and then absolute value side right here, and press enter. It's gonna be right here. Now hit tab, input the second equation. It's gonna be 2 right here, and then press enter, right? Now you need to restrict the domain from 2 to 4, right? So hit menu, number 4, number 1, as minimum 2, as maximum 4, press OK. Alright, so you have 2 intersections right here and right here, right? Now you're gonna press menu, go to number 6, number 4, go to the left, go to the right. The first intersection right here, 3.13. Hit menu, analyze graph, number 4, the left, the right. It's gonna be right here. So it could be 3.13 and 3.47, right? Now question B. Write an expression involving an interval that gives the position s of t. Use this expression to find the position of the particle at time t equals 5, right? So s of t equals s of 0 plus interval from 0 to t, right? V of s ds, right? S of t equals s of 0 equals 10 right here, plus interval from 0 to t, v of s ds, right? Now we need to find s of 5, right? So we have s of 5 equals 10 plus interval from 0 to 5 of v of s ds. Press 10 plus the button right here, put the interval right here, 0 to 5, right? And then you just input the function v of t right here. Press Ctrl Enter. It's gonna be negative 9.207. Now question C. Find all times t in the interval 0 to 5 at which the particle changes direction. So we just let v of t equals 0. We're gonna find the critical numbers, and then we're gonna create the side charge, right? So v of t is right here. Now we're gonna print up the calculator. Now this one is the function of v of t. You need to find the 0 of v of t, right? Because this one equals 0. So you have 3 0 right here, 1, 2, and 3, right? So you need to hit menu, number 6, number 1, right? The first 0 right here, right? Now menu, number 6, number 1. The second 0 is right here. And the third one is right here. Alright. Negative 0.668, 0.536, and 3.32. Now we're gonna look at the domain right here. T must be between 0 and 5, right? So we only pick the positive value of t, right? Now we're gonna draw the number line. Place these two values on the number line. So I'm gonna pick 0 on this interval, right? So I substitute 0 for t over here. I get negative 2, which is negative side, right? This guy negative, this guy must be positive, and this guy negative. Now at t equals 0.536, v of t changes sign from negative to positive, right? At t equals 3.32, v of t changes sign from positive to negative, right? Therefore, the particle changes direction at time t equals 0.536 and t equals 3.32, right? Now let's move on to question D. Is the speed of the particle increasing or decreasing at time t equals 4? So when it comes to the speed, make sure you check the sign of v of t and a of t at t equals 4 right here. Right? If v of t and a of t have the same sign, the speed is increasing. If v of t and a of t have opposite sign, then the speed is decreasing, right? So v of 4 is and a of 4 is. Now we're gonna print up the calculator. We're gonna go to the home screen, hit calculate. Now we need to store the function v of t, right? So I'm gonna copy this one over here. Right? Now I need to hit v of ask, right? Hit the control and the button right here and then press enter. I just store the function, right? Now I need to calculate v of 4, right? So I just hit v of 4 and then press control enter. It's gonna be negative 11.457, right? Now I need to calculate a of 4. So I need to calculate the derivative of v of t right here and evaluate the value at t equals 4, right? So I'm gonna go to menu, calculus, and derivative at a point right here, right? The variable in this situation I use as, I just keep it, right? The value should be 4, right? And then press OK right here. Now I just input v of x, right? And then press Ctrl Enter. It's gonna give you negative 22.2957, right? Now observe that v of 4 is negative, a of 4 is negative. So v of 4 and a of 4 have the same sign. Then the speed is increasing, right? Now let's move on to question 16. A particle moves along the y-axis with the velocities given by this function for t greater than or equal to 0. Question A. In which direction, up or down, is the particle moving at time t equals 1.5? Right, so we're going to calculate v of 1.5. It's going to be 1.5 times sine of 1.5 square, right? So we're going to print up the calculator. At calculator, 1.5 times sine of 1.5 square. Press Ctrl Enter. It's going to be 1.167, right? This value is greater than 0. It tells us that the particle moving up. Question B. Find the acceleration of the particle at time t equals 1.5. Right? You know that acceleration is the first derivative of the velocity, right? So it's gonna be, you're gonna use the product rule, right? So it could be sine t squared, right? Plus derivative of this one, it could be 2t times cosine t squared. So it's gonna be sine t squared plus 2t squared times cosine t squared, right? So we need to calculate a of 1.5. It's gonna be v prime of 1.5, right? So it's gonna be sine of 1.5 square plus 2 times 1.5 square times cosine of 1.5 square, right? So we're gonna print up the calculator. We're gonna hit trick sine of 1.5 square plus 2 times 1.5 square times cosine of 1.5 square. Press Ctrl Enter. It's going to be negative 2.048. This guy less than 0. So you know that if the first derivative less than 0, the function is decreasing, right? So you need to say no. The function v of t is decreasing at time t equals 1.5. Now let's move on to question C. Given that y of t is the position of the particle at time t and that initial condition is right here. Find y of 2, right? So you know that position function is the antiderivative of the velocity function, right? So y of t is antiderivative of v of t dt, right? So we're going to take antiderivative of t times sine t squared dt, right? So we're going to use u substitution, right? So we're going to let u equals t squared. Then du equals 2t dt. So we look at this guy right here, t and dt, which is this one right here, right? So we need to isolate t and dt. It's going to be du divided by 2, right? So we substitute back over here. We have y of t equals antiderivative of sine u times du, and then put 1/2 in the front, right? So it could be antiderivative of sine u is going to be negative cosine u, right? Don't forget 1/2 here plus c. But u is equal to this one, right? So it could be negative 1/2 cosine of t squared plus c, right? Now we need to use the initial condition right here to solve for c, right? So we have y of 0 equals 3, which means t equals 0 and then y equals 3, right? So we have negative 1/2 cosine of 0 plus c equals 3, right? So then negative 1/2 cosine of 0 equals 1, right? Plus c equals 3. And then c equals 7/2. Now we substitute this guy back over here. So we have equation of y of t, right? So y of t equals negative 1/2 cosine of t squared plus 7/2. Now we need to calculate y of 2, right? So y of 2 equals negative 1/2 cosine of 2 squared plus 7/2. Alright, so we're gonna print up the calculator. Negative 1/2, which means negative 0.5, right? Times cosine of 2 squared equals 4, right? Plus 7/2, which is 3.5, right? Press Ctrl Enter. It's gonna be 3.826, right? Now question D. Find the total distance traveled by the particle from t equals 0 to t equals 2. The distance traveled by the particle is given by the formula. The integral from 0 to 2 of absolute value of v of t dt, right? So then it's going to be integral from 0 to 2 of absolute value of t sine of t squared dt, right? So we're going to print up the calculator. We're going to press the button right here, hit the integral right here, right? From 0 to 2. Right here, we're going to hit the button right here, pick the absolute value side right here, right? So we're going to put t times sine of t squared, then dt right here. Press Ctrl Enter. It's going to give you 1.173, right? Now let's move on to question 17. A particle moves along the x-axis so that its velocity v at time t between 0 to 5 is given by this function. The particle is at position s equals 8 at time t equals 0. Question A. Find the acceleration of the particle at time t equals 4, right? So you know that acceleration is the first derivative of the velocity function, right? So we have a of t equals v prime of t, right? So you know that ln of u prime is going to be u prime over u, right? So it's going to be 2t minus 3 over t squared minus 3t plus 3, right? So you have a of 4 equals v prime of 4, right? So substitute 4 for t. It's going to be 5 over 7. Now let's move on to question B. Find the times t in the open interval 0 to 5 at which the particle changes direction. During which time intervals t between 0 to 5 does the particle travel to the left? Basically, we just let v of t equals 0, right? So it turns out to be ln of t squared minus 3t plus 3 equals 0, right? This guy the same thing as t squared minus 3t plus 3 equals 1, right? Because you have ln of 1 equals 0, right? So you have t squared minus 3t subtract 1 both sides, it could be plus 2 equals 0, right? Now factor this one, so it could be t minus 1 times t minus 2 equals 0, right? So then t equals 1 and t equals 2, right? Now we're going to put this one on the side chart, right? 1 and 2, right? This one is 0, this guy is 5, right? Now I'm going to test the interval, right? So I'm going to test this interval, right? So I pick 3 over here. Substitute 3 for t back to this equation right here, right? So I have 3 minus 1, 3 minus 2, which is positive, right? So this interval is positive, and you keep changing side. This is negative, this is positive, right? So you know that if t greater than 0, less than 1, or 2 less than t less than 5, v of t is positive, right? If 1 less than t less than 2, then v of t is negative, right? So the question asks you to find the times t in the open interval which the particle changes direction. So the particle changes direction at t equals 1 and t equals 2, right? Change from positive to negative, negative to positive, right? And during which time intervals does the particle travel to the left, which is v of t is less than 0, right? So this interval right here, the particle travel to the left. Now question C. Find the position of the particle at time t equals 2. Alright, you given the initial condition right here. At t equals 0, s equals 8, right? So we're going to use the fundamental theorem of calculus, right? So we have the final position, which means s of 2, right? Equals initial position is going to be s of 0, right? Plus the interval from 0 to 2 of the velocity function, right? So we're going to substitute s of 0 equals 8 plus the interval from 0 to 2 of ln of t squared minus 3t plus 3 dt, right? Now we're going to print up the calculator. So I have 8 plus, hit the button right here, input the integral symbol. the interval from 0 to 2 of control enter. It's going to be 8.38. Now question D. Find the average speed of the particle over the interval 0 to 2. Alright, you know that the speed of the particle over this interval is going to be interval from 0 to 2 of absolute value of v of t dt, right? Now the average, which means 1 over b minus a, but b equals 2, a equals 0, right? So you have 2 minus 0, it could be 1/2, right? So we're gonna bring up the calculator. 1/2, which means 0.5, right? I copy this one down over here. I put this guy inside the absolute value sign, right? So I need to hit the button right here, hit this guy, right? And then press Ctrl Enter. It's gonna be 0.370, right? Now let's move on to question 18. A particle moves along the x-axis so that the velocity at time t for t between 0 and 6 is given by a differentiable function v whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5, right? Which is the 0 right here. And the graph has horizontal tangent line at t equals 1 right here, and t equals 4 right here. The areas of the regions bounded by the t-axis and the graph of v on the interval 0 to 3, which is this guy, 3 to 5, which is this guy, and 5 to 6, which is this guy, right? 8, 3, and 2 respectively. At time t equals 0, the particle is as s equals -2. So you have s of 0 equals -2, right? Now question A. For t between 0 and 6, find both the time and the position of the particle when the particle is farthest to the left. Alright, now the particle is farthest to the left. It tells us that velocity always less than 0, right? So we consider the interval from 0 to 3 and 5 to 6, right? Because at these two intervals, the velocity is below the axis, so it can be negative, right? So we need to find the position function at t equals 3, 5, and 6, right? It's going to be this guy, and this guy, right? Now we're going to use the fundamental theorem of calculus, right? So we have the final position s of 3 equals s of 0, right? Plus the interval from 0 to 3 of v of t dt, right? So s of 0 is given by -2 right here, right? Plus interval from 0 to 3, which is the area under the curve, right? Which is the yellow one right here. And this guy actually -8, right? Given right here. So plus -8. And it's going to be -10, right? Now s of 5, it's going to be s of 0 plus interval from 0 to 5 v of t dt, right? So it's going to be s of 0 equals -2, interval from 0 to 5, which is -8 plus 3 right here, right? So it's going to be -7. And finally, s of 6 is going to be s of 0 plus interval from 0 to 6 v of t dt, right? So it could be -2. Now -8 plus 3 minus 2 right here, right? So negative 8 plus 3 minus 2. So it could be negative 9, right? Now we're gonna look at these three values right here. This one is the smallest one, which is the farthest one, right? Now question B. For how many values of t where t between 0, 6 is the particle at s equals negative 8? Explain your reasoning. Alright, so you know that s of 0 equals negative 2 and s of 3 equals negative 10, right? Within the interval 0 to 3, we get this one. Now, the next interval from 3 to 5, we get s of 3 equals negative 10 right here. And s of 5 equals negative 7, right? And the last interval from 5 to 6, you have s of 5 equals negative 7 and s of 6 equals negative 9, right? Now we're going to look at this guy right here, s equals negative 8. We're going to use the intermediate value theorem, right? Negative 8 is between negative 10 and negative 2, right? Negative 8 between negative 7 and negative 10. Negative 8 between negative 9 and negative 7. So by the intermediate value theorem, there is a number t in this interval such that negative 8 between these two numbers, right? Now, question C. On the interval 2 to 3, is the speed of the particle increasing or decreasing? Alright, the speed is increasing or decreasing. We're going to talk about the sign of the velocity and acceleration. If the velocity and acceleration have the same sign, the speed of the particle is increasing. If the velocity and acceleration have the opposite sign, the speed of the particle is decreasing, right? So we're going to check for v of t and a of t for t between 2 and 3, right? So we look at the graph right here, 2 to 3, which is this guy right here only, right? Within this interval. Alright, so within this interval, you know that v of t is below that axis, right? So v of t is less than 0, right? But a of t is the first derivative of v of t, which is the slope of the tangent line, right? So we draw the tangent line right here. We see that the tangent line is going up, the slope is positive, so a of t is positive, right? Use the Christmas tree trick, right? The line is going up, slope positive, line is going down, slope negative, 0 and undefined. Right, so v of t and a of t have the opposite sign. The speed of the particle is decreasing. Question E. During what time intervals, if any, is the acceleration of the particle negative? Alright. So we're going to look at the graph right here. Oh, the function v of t is decreasing, right? So we look at this guy right here. The function v of t is decreasing on this interval, right? And this guy right here, right? So it's going to be from 0 to 1, right? And 4 to 6, right? Now let's move on to question 19. Ben rides a unicycle back and forth along a straight east-west track. The choice differentiable function B models Ben's position on the track, measured in meters from the western end of the track at time t, measured in seconds from the start of the ride. The table gives value for b of t and Ben's velocity v of t measured in meters per second at selected time t. Question A. use the data in the table to approximate Ben's acceleration at time t equals 5 seconds. So you know that t equals 5 between 0 and 10, right? So you have A of 5 is approximately V of 10 subtract V of 0 over 10 minus 0, right? So it's going to be V of 10 equals 2.3 subtract 2 divided by 10, right? So it could be 0.3 divided by 10. It's going to be 0.03 meter per second square, right? Now question B. Using correct units, interpret the meaning of the interval from 0 to 60 of absolute value of V of t dt in the context of the problem. Alright, so the interval from 0 to 60 of absolute value of V of t dt is the total distance in meters that Ben rides over the 60-second interval t equals 0 to t equals 60, right? Now, approximate the interval from 0 to 60 of absolute value of V of t dt using a left remain sum with the subintervals indicated by the data in the table. Alright, so we look at the table right here. We have 3 intervals, right? 1, 2, and 3. The interval from 0 to 60 of absolute value of V of t dt equals. Now the first interval from 0 to 10 and the width should be 10 minus 0, right? Times the height, which means 2.0, right? Because we're going to use the left remain sum, right? Plus the second interval from 10 to 40, right? So you have 40 subtract 10 times the height is going to be 2.3. And the last one, the interval from 40 to 60, right? Plus 60 subtract 40 times the height is going to be 2.5. And the answer should be 139 meters. Now question C. For t between 40 and 60, must there be a time t when Ben's velocity is 2 meters per second? Alright. Now you have V of t equals B of 60 subtract B of 40 over 60 subtract 40, right? So it's going to be B of 60 is going to be 49 subtract 9 divided by 20, right? So it's going to be 40 divided by 20. It's going to be 2. And this guy right here is exactly this guy right here, right? So we're going to apply the mean value theorem, right? So we need to say that by the mean value theorem, there is a time t between the interval 40 to 60 such that V of t equals 2, right? Question 11. The volume of a spherical hot air balloon expands as the air inside the balloon is heated. The radius of the balloon in feet is modeled by a choice differential function of time t, where t is measured in minutes. For t between 0 and 12, the graph of R is concave down. The table above gives selected values of the rate of change of round of t of the radius of the balloon over the time interval 0 to 12. The radius of the balloon is 30 feet when t equals 5. Question C. Use a right remain sum with the 5 subintervals indicated by the data in the table to approximate the interval from 0 to 12 of R' t dt. Using the correct units, explain the meaning of the interval from 0 to 12 of R' t dt in terms of the radius of the balloon. Alright. Now, right remain sum 5 subinterval, right? So the width right here 2, 3, 2, 4, and 1, right? So right remain sum, you need to pick the high right here, 4, 2, 1.2, 0.6, and 0.5, right? So the interval from 0 to 12 of our gram of t dt equals length times width, right? So you have 4 times 2 plus 2 times 3 plus 1.2 times 2 plus 0.6 times 4 plus 0.5 times 1, right? And it's going to be 19.3 feet. Now, we need to explain the meaning of this one in terms of the radius of the balloon. So we need to say that the interval from 0 to 12 of r prime of t dt is the change in the radius in feet from t equals 0 to t equals 12 minutes. Now question D. Is the approximation in part C greater than or less than the interval from 0 to 12 of r prime of t dt? Alright, now we go back over here. Since the graph of r is concave down, it tells us that r double prime less than 0, right? Then r prime is decreasing, right? And we use the right remain sum right here, right? So using right remain sum for the decreasing function, it tells us that the approximation is less than the interval from 0 to 12 of r prime of t dt, right? Now let's move on to question 12. Ben rides a unicycle back and forth along a straight east-west track. The track's differential function B models Ben's position on the track, measured in meters from the western end of the track. At time t, measured in seconds from the start of the ride. The table gives value for b of t and Ben's velocity v of t measured in meters per second at selected times t. Question B. Using correct units, interpret the meaning of interval from 0 to 60 absolute value of v of t dt in the context of the problem. Approximates the interval from 0 to 60 absolute value of v of t dt using a left remain sum with the subintervals indicated by the data in the table. Alright, so you know that the interval from 0 to 60 of absolute value of v of t dt actually the total distance in meters that Ben rides over the 60-second interval from t equals 0 to t equals 60. Alright, now we're going to use the left remain sum to approximate this one, right? So the interval from 0 to 60 absolute value of v of t dt equals the width right here 10, right? This is 30 and this is 20, right? Now the height is to be 2, 2.3 and 2.5, right? So we have 2 times 10 plus 2.3 times 30 plus 2.5 times 20, right? So the answer is 139 meters. Now let's move on to question 13. Train A runs back and forth on an east-west section of railroad track. Train A's velocity is measured in meters per minute. Is given by a differential function Va of t, where time t is measured in minutes. Selected values for Va of t given in the table above. At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an interval that gives the position of train A in meters from the origin station. At time t equals 12, use the trapezoid sum with the 3 subintervals indicated by the table to approximate the position of the train at time t equals 12, right? Remember, we have the final position equals initial position plus the interval from initial to final of v of t dt, right? as A of 12, right? The final one right here, initial is right here, equals as A of 2 plus integral from 2 to 12 of V A of T dt, right? Now, SI of 2 is 300 right here, right? Plus the integral from 2 to 12 VA of T dt, right? Now, use a trapezoidal sum with 3 subintervals, right? We need to calculate this one, right? So, the integral from 2 to 12 V sub A of T dt is approximately, now, the width right here, 2. The width right here is 3. This is 3 and this is 4, right? So, base 1 is 0, base 2 is 100. The height should be the width, right? So we have 0 plus 100 times 2 divided by 2 plus 100 plus 40 times the height right here 3 divided by 2 plus 40 plus negative 120 times the height right here 3 divided by 2, and the last one negative 120 plus negative 150 times the height is 4 right here divided by 2, right? So it's approximately negative 450, right? So the position of the train at time t equals 12 is S sub A of 12 equals 300 right here. Subtract 450, right? So it can be negative 150, right? Now we're gonna sketch the diagram, right? This is north, this is south, this is east, and this is west, right? So at time t equals 2, we have the train A position is 300 meters east of the origin station, right? So it's right here, 300, right? Now at time t equals 12, we get negative 150. So negative 150, it tells us that it's gonna go opposite direction, right? So this is positive, this is negative right here, right? So 150 should be right here. And the negative side right here tells us that it goes opposite direction, right? So the position of train A at time t for 12 minutes is approximately 150 meters west of origin station. Now let's move on to question 14. Hot water is dripping through a coffee maker. Fill in a large cup with coffee. The amount of coffee in the cup at time t from 0 to 6 is given by a differential function c, where t is measured in minutes. Select the value of CFT is measured in ounce, all given in the table above. Question C. Use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of interval from 0 to 6 CFT dt divided by 6. Using correct units, explain the meaning of this one in the context of the problem. Alright, so we have the interval from 0 to 6 of C of t dt divided by 6. It's going to be approximately, now we're going to use the midpoint sum, right? 3 subintervals, right? So the first interval right here, right? The second interval is right here, and the third interval right here, and the midpoint is right here, right? So we have the width right here is going to be 2, 2, and 2. So length times width, length is 5.3 right here, times the width is 2, plus 11.2 times 2, plus 13.8 times 2, right? And don't forget to divide by 6 right here, right? So it's going to be 10.1 ounce. To explain the meaning of this one in the context of the problem, we need to say that the integral from 0 to sit CFT dt divided by sit is the average amount of coffee in the cup in ounce over the time interval from 0 to 6 minutes. Because this guy is actually the average value of the function, use the formula 1 over b minus a, the integral from a to b of f of s ds, right? Now a equals 0, b equals 6, that's why 6 subtract 0 is going to be 6. Question 18. Let f be a function that is twice differentiable for all real numbers. The table above gives value of f for selected points in the closed interval 2, 13. Question B. Evaluate the integral from 2 to 13 of 3 minus 5 f prime of s ds. This guy turns out to be the integral from 2 to 13 of 3 ds minus 5 the integral from 2 to 13 of f prime of s ds, right? So it's going to be 3s evaluated from 2 to 13 minus 5 times f of 13 minus f of 2, right? So we're going to plug in values. So 3 times 13 it could be 39. Subtract 6, right? Minus 5 times f of 13 equals 6. F of 2 equals 1, right? So it could be 33 subtract 25. It could be 8. Now question 19. The function g is defined and differentiable on the closed interval -7 to 5 and satisfy g of 0 equals 5. The graph of y equals g prime of s. The derivative of the function g consists of a semicircle and 3 line segments as shown in the figure above. The final value is g of 3 equals initial value, which means g of 0 plus the integral from 0 to 3 of g prime of s ds, right? So g of 0 equals 5, right? Now the integral from 0 to 3 of g prime of s ds, this is the g prime right here, 0 to 3, 0 right here, and 3 is right here, right? So this is actually the error under the curve, right? This one is the quarter circle, right? And this one right here is the right triangle, right? The base is 1, the height is 3, right? The radius of this one is 2, right? So it could be pi times 2 squared divided by 4, right? Plus 1 times 3 divided by 2. Now we're going to simplify this one. It's going to be 5 plus pi plus 1.5, right? So it could be 6.5 plus pi, right? Now g of -2, we do exactly the same thing, right? It's going to be g of 0 plus the integral from 0 to -2 of g prime of s ds, right? G of 0 actually 5, right? Subtract the integral from -2 to 0 of g prime of s ds, right? Now it's going to be 5 subtract the integral from -2 to 0. It's going to be right here. And it's actually the quarter circle right here, right? So the area of the quarter circle of this one equal this one, right? It's actually right here. It's actually pi, right? So the answer is 5 minus pi. Now question 20. As a part of T cools, the temperature of the T is modeled by a differentiable function h for T between 0 and 10, where time T is measured in minutes and temperatures h of T is measured in degrees Celsius. Values of h of T at selected values of time T shown in the table. Question C. Evaluate the interval from 0 to 10 of h prime of t dt using correct units and explain the meaning of the expression in the context of this problem. Alright, so the interval from 0 to 10 of h prime of t dt is h of 10 subtract h of 0, right? By fundamental theorem of calculus, right? So h of 10 is 43. H of 0 is 66. So it's going to be negative 23. Question D. At time t equals 0, biscuits with temperatures 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by a differentiable function b, for which is known that b prime of t equals this guy. Using the given models, at time t equals 10, how much cooler are the biscuits than the tea? Alright, so t equals 10 is the final, right? T equals 0 is the initial, right? So we have b of 10 equals b of 0 plus the interval from 0 to 10 of b prime of t dt, right? So it's going to be 100, right? Initial one right here, plus the interval from 0 to 10 of negative 13.84 e to the negative 0.173 t dt, right? So we're going to bring up the calculator. Hit home screen, go to calculate. 100 plus the interval from 0 to 10 and press Ctrl Enter. It's going to be 34.183. We need to find the difference in degrees Celsius between H and B, right? So we have H of 10 subtract B of 10 equals H of 10 is 43 right here. Subtract 34.183, right? So it could be approximately 8.817. Now let's move on to question 21. At a certain height, a tree trunk has a circular cross-section. The radius r of t of that cross-section grows at a rate modeled by the function right here, centimeters per year, for t between 0 to 3, where time t is measured in years. At time t equals 0, the radius is 6 centimeters. The area of the cross-section at time t is denoted by a of t. Question A. Write an expression involving an interval for the radius of t for t between 0 to 3. Now, since t is between 0 to 3, right? So we have the final amount r of t right here equals initial amount, which means r of 0, right? Look, this one, plus the interval from 0 to t of r prime of s ds, right? So it's going to be 6 plus the interval from 0 to t of 1 over 16 times 3 plus sine of s squared ds, right? You just change the variable right here. Alright, so we need to calculate r of 3. So we have r of 3, substitute 3 for t. So it could be 6 plus interval from 0 to 3. Now I'm going to copy this one down over here. I just change the number. Press Ctrl Enter. It's going to be 6.611, right? Now let's move on to question C. Evaluate the interval from 0 to 3 a prime of t dt. So the interval from 0 to 3 of a prime of t dt equals a of 3 minus a of 0. Now since the cross-section is circular, right? And the radius of 3 is 6.611, right? So the error must be pi times r squared, right? And r is right here. So it can be 6.611 square times pi, right? Subtract a of 0, substitute 0 for t over here to find the radius, right? So this guy actually 0, right? So we have 6 left right here. So it could be 6 square times pi, right? So we're gonna print up the calculator. We're gonna square the answer right here, right? Subtract 6 square, which means 36, right? Press enter. And then we need to multiply by pi. And then press Ctrl enter. It's gonna be 24.201, right? Now we need to interpret the meaning of that interval in terms of cross-sectional error. So we need to say from time t equals 0 to 3 years, the cross-sectional error grows by 24.201 square centimeters. Now let's move on to question 22. Let G be the piecewise linear differential function on negative 2 pi to 4 pi, whose graph given above. And let Fs equal g of s minus cosine s over 2. Question A. Find the interval from negative 2 pi to 4 pi of Fs ds. Alright, so this guy actually the interval from negative 2 pi to 4 pi of this guy right here, right? So it's gonna be the interval from negative 2 pi to 4 pi of g of s ds minus the interval from negative 2 pi to 4 pi of cosine of s over 2 ds, right? Now, the interval from negative 2 pi to 4 pi of g of s actually the area of the triangle right here, right? The base is 4 pi subtract negative 2 pi, which means 6 pi, right? The height right here is 2 pi, right? So this guy turns out to be 6 pi times 2 pi divided by 2, right? 2 sine of s over 2 evaluated from negative 2 pi to 4 pi, right? Remember antiderivative of cosine of as plus b ds is going to be 1 over a sine of as plus b plus c, right? Antiderivative of sine of as plus b ds is going to be 1 over a cosine of as plus b plus c, right? Antiderivative of e to the as plus b ds is going to be 1 over a e to the as plus b plus c. So keep that in mind, right? In this situation, we just rewrite this one as cosine of 1/2 s, right? So that's why we get this one, right? So 6 pi times 2 pi is going to be 12 pi squared divided by 2 is going to be 6 pi squared minus substitute 4 pi for s is going to be negative 2 times sine of 4 pi divided by 2 subtract sine of negative 2 pi divided by 2, right? So it could be 6 pi squared minus 2. 4 pi divided by 2, it could be 2 pi sine 2 pi equals 0, right? Minus sine of negative pi, right? So it could be 6 pi squared minus 2. Now, sine of negative pi is going to be negative sine of pi, right? Negative is going to be positive, right? But sine of pi equals 0, so it could be 0 right here. The answer should be 6 pi squared. Now let's move on to question C. Let h of s equals the interval from 0 to 3s of g of t dt. We need to calculate h prime of negative pi over 3. So we have h prime of s equals g of 3s, right? Times the derivative of this one is actually 3, right? So I put 3 in the front. Now we have h prime of negative pi over 3 equals 3 times g of negative pi, right? Negative pi is right here, right? Now we don't know the value of g of negative pi, right? We cannot guess, right? So we need to write equation of the line right here, right? So you see that the slope actually 2 pi divided by 2 pi is going to be 1, right? And the y-intercept is 2 pi right here, right? So we just name this one is A and this one is B, right? So we need to write equation in slope-intercept form, right? Y equals ms plus b, right? I call the function g of s as the equation of the line AB, right? Equals the slope actually 1, right? Because 2 pi divided by 2 pi is going to be 1 times s plus the y-intercept is 2 pi, right? So we're going to go back over here. So it's actually 3 times negative pi plus 2 pi. It's going to be 3 times pi, right? Question 23. The function f is defined on the closed interval -5 to 4. The graph of the function f consists of 3 line segments and is shown in the figure above. Let g be the function defined by g of s equals the interval from -3 to s f of t dt. Question B. On what open intervals contained in -5 to 4 is the function of g both increasing and concave down? Now, from this one, we need to calculate g prime of s is actually f of s, right? And g double prime of s is actually f prime of s, right? Now, g is increasing. It tells us that g prime of s must be greater than 0, right? And concave down, it tells us that g double prime of s must be less than 0, right? Now we go back over here. G double prime of s less than 0, it tells us that f prime of s must be less than 0, right? And this guy tells us that the function f of s is decreasing, right? Now, g prime of s greater than 0, it tells us that f of s must be greater than 0, right? If f of s greater than 0, the function f must be above the axis, right? So we need to look for the interval where the function f is above the axis and decreasing, right? So it could be right here and right here, right? So the answer must be the interval from -5 to -3 and 0 to 2, right? Now let's move on to question 24. The rate at which rainwater flows into the drain pipe is modeled by the function R, where R t equals this guy, cubic feet per hour. T is measured in hours, and T between 0 to 8. The pipe is partially plugged, allowing water to drain out the other end of the pipe at a rate modeled by d of t equals this guy, cubic feet per hour. For t between 0 to 8, there are 30 cubic feet of water in the pipe at time t equals 0. Question A. How many cubic feet of drained water flow into the pipe during the 8-hour time interval t between 0 and 8, right? So it's going to be the interval from 0 to 8 of r of t dt, right? So it could be interval from 0 to 8 of 20 sine of t squared over 35 dt, right? So we're going to bring up the calculator. Press Ctrl Enter. It could be 76.570. Now question C. At what time t between 0 to 8 is the amount of the pi at a minimum, right? So we're going to let the function p of t, right? It's actually equals initial amount right here, 30, plus the interval from 0 to t, right? T between 0 to 8 of rate in is right here. So we're going to change it to R of S. Subtract rate out is going to be right here. D of S ds, right? Now, to find the minimum, we need to find the first derivative, right? So, we're going to take derivative of this one. So, p prime of t equals this guy, derivative equals 0, right? Derivative of this one, just print t over here, right? So, we have r of t minus d of t, right? So, p prime of t equals 0 when r of t minus d of t equals 0, right? So basically, we just grab these two guys. So then, we're going to use the intersection. Make sure t between 0 to 8, right? So we're going to print up the calculator. Hit the graph right here. Hit the tab. Go to F1. Change the function. Right? R of t is right here. Press enter. Now F2 is this guy right here. After you input two functions on the same x and y coordinate plane, you're gonna get this one right here. Now you need to hit menu, window setting right here. You need to restrict the domain from 0 to 8. Alright, it's gonna be right here. Now we need to find the intersection. This guy is the solution. So press menu, number 6, number 4. Go to the left, go to the right. The answer is 3.27. Since this one is the closed interval, we need to use the candidate test, right? So we need to get the t charge, right? Now t equals 0, substitute 0 for t into this equation right here, right? So this guy actually 0, we have 30 left right here, right? So it could be 30. Now t equals 3.27. Substitute 3.27 for t into this one right here, right? So we need to print up the calculator. Hit home screen, go to calculate, press Ctrl Enter. It's going to be 27.965. T equals 8. Substitute 8 for t into this one. So we're gonna print up the calculator. I'm gonna copy this one down over here. Right? So I just changed the upper bar right here to 8. That's it. And then press Ctrl Enter. It's gonna be 48.544, right? Alright, so the minimum value is right here at t equals 3.27, right? So we need to say the amount of water in the pipe is minimum at time t equals 3.27. 11. Consider the differential equation dy over dx equals 3 minus y times cosine x. Let y equals fs be the particular solution to the differential equation with the initial condition f0 equals 1. The function f is defined for real numbers. Question A. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So x equals 0, y equals 1. It's going to be right here. The graph should be something like this. Now question B. Write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So we have dy over dx equals 3 minus y times cosine x, and then initial condition is right here, right? So we need to find the slope of the tangent line dy over dx equals 3 minus y times cosine x. So dy over dx evaluated at the point 0, 1 equals 3 minus 1 times cosine 0. So it could be 2, right? Then equation of the tangent line is f of s equals the slope is 2 times s minus 0, right? Plus 1, right? So then we need to evaluate this one, right? So f of 0.2 equals 2 times 0.2 minus 0 plus 1. So it could be 0.4 plus 1 is going to be 1.4. Now question C. Find y equals fs, the particular solution to the differential equation with the initial condition right here. So we need to separate the variable, right? So this guy turns out to be dy over 3 minus y equals cosine s ds, right? So we need to take antiderivative both sides, right? So this guy turns out to be antiderivative of d of 3 minus y over 3 minus y. Now, if you take derivative of this one, it's actually negative dy, right? But we have dy over here, so I just put the negative side in the front. Equals sine s plus c, right? Now remember, if you have antiderivative of du over u, it's going to be ln of absolute value of u plus c, right? U in this situation is 3 minus y, right? Make sure this guy and this guy must be the same, right? So you have negative ln of absolute value of 3 minus y equals sine s plus c. Now I'm going to use the initial condition right here to solve for c, right? So I have negative ln of absolute value of 3 minus 1 is going to be 2. But 2 is positive. I can eliminate the absolute value side, right? Now sine of 0 equals 0, so it could be c, right? So c equals negative ln 2. Substitute this guy back over here, right? So we have equation negative ln of absolute value of 3 minus y equals sine s minus ln 2, right? Now we need to solve for y, right? Now we need to find ways to remove the absolute value side right here, right? Observe that the initial condition is f of 0 equals 1. It tells us that y equals 1, right? But 1 is less than 3, right? So this guy is the same thing as 3 minus y greater than 0, right? So remember, if you have absolute value of s, it's going to be equals s if the one inside the absolute value side right here greater than or equal to 0, right? So when you remove the absolute value side, you don't need to change anything, right? Now, absolute value of s equals negative s if s less than 0, right? So we look at this one. This guy fall into the first case right here, right? Greater than 0, don't change anything, right? So we have negative ln of 3 minus y equals sine s minus ln 2, right? Multiply both sides by negative 1, right? So this guy becomes negative, this guy becomes positive, and I need to eliminate this one, right? We need to exponentiate both sides, right? So it's going to be 3 minus y equals e to the negative sine s times e to the ln 2, right? So then this guy turns out to be 3 minus y equals 2 times e to the negative sine s, right? And then y equals 3 minus 2 times e to the negative sine s is the final answer. Question 12. Consider the differential equation dy over dx equals 2x minus y. On the axis provided, sketch the slope field for the given differential equation at the set points indicated. Alright, use the Christmas tree trick. The lines going this way, slopes positive. This guy negative, 0 and undefined, right? So look at the first one right here. This guy s equals 1, y equals 1. Substitute over here. So we have dy over ds equals 2 times 1 minus 1 is going to be 1, right? This guy right here, s equals 1, y equals 2. Substitute over here, so you have dy over ds equals 2 times 1 minus 2 is going to be 0, right? Now for this point right here, s equals 1, y equals negative 1. So then dy over ds equals, substitute over here, we have 3. Now for this point right here, s equals 0, y equals negative 1. Substitute over here, we have dy over ds equals 1, right? This point, s equals 0, y equals 1. So dy over ds equals negative 1. And the last one, s equals 0, y equals 2. dy over ds equals negative 2, right? Now go back to the Christmas tree trick. If the line is going this way, the slope is because the line is steeper. The line is going this way, smaller slope, steeper line. Alright, so we're gonna start with this guy first. The slope is 0. Look at the Christmas tree. It should be the horizontal line. So it will be like this. Now look at 1 right here. You can rewrite 1 over 1, right? So this guy actually rises over 1, right? You're gonna start from here, go to the left 1, go down 1. So it will be right here. So you just connect this one, and this is the slope right here. This one can be written as 3 over 1, right? So rise over 1, 3 over 1. We're gonna go up 3, right? So 1, 2, 3. And go to the right 1, right? So it could be something like this, right? So we connect this guy right here, right? So the slope here should be like this. Now for this one right here, the slope is 1, right? So 1 over 1 is going to be like this, right? So you can go up 1, go to the right 1. So it could be something like this, right? And the final slope here should be this guy right here. Now for this guy right here, the slope is negative, right? So I'm going to start from here. Go down 1, go to the right 1. So it could be like this, right? So the slope here should be this one. Now the last one, the slope is negative 2. It's going to be negative 2 over 1, right? So we're going to start from here, go down 2, go to the right 1, right? So it could be like this. So the slope here should be this one, right? So finally, I need to remove the dotted line. Now question B. Find the second derivative in terms of s and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. So we have dy over ds equals 2s minus y, right? We're going to take derivative both sides with respect to s, right? So it could be d squared y over ds squared equals 2 minus dy over ds, right? But dy over ds equals this guy, right? So it could be 2 minus 2s plus y, right? Now we need to determine the concavity of all solution curves for the given differential equation in quadrant 2. So observe that in the second quadrant, s is negative, y is positive, right? So this guy right here, the second derivative, always positive, right? Then all solution curves always concave up in the quadrant 2. Now question C. Let y equals f as be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have the relative minimum, maximum, or neither? S equals 2. Alright, so when it comes to minimum, maximum, we need to find the critical numbers, right? So critical number is the solution of y prime equals 0, right? So we have dy over ds, which is y prime is going to be 2s minus y, right? we have the initial condition right here. Substitute 2 for s and 3 for y. So it will be 4 minus 3 is going to be 1. This guy not equal to 0, right? So we cannot find the critical numbers. So we need to say the function f has neither a relative minimum nor a relative maximum at s equals 2. Now let's move on to question D. Find the values of the constant m and b, for which y equals ms plus b is a solution to the differential equation. Alright, so we have y equals ms plus b. We need to take derivative both sides with respect to s, right? So we have dy over dx equals m, but dy over dx equals 2s minus y right here, right? So we need to let 2s minus y equals m, right? So then we have 2s minus y equals ms plus b right here, right? ms plus b equals m, right? So then you have 2s minus ms minus b equals m, right? So then you have 2 minus m times s, right? Subtract m both sides, so it will be negative b plus m equals 0, right? Now 0 right here can be written as 0s plus 0, right? So I just equate the coefficient right here. So I have a system of two equations. 2 minus m equals 0, negative b plus m equals 0, right? I solve a system of two equations right here. M equals 2. Substitute 2 for m right here. So b equals negative 2, right? Now let's move on to question C. Find the particular solution w equals wt to the differential equation dw over dt equals 1 over 25 times w minus 300 with initial condition w0 equals 1400, right? So we need to separate the variable, right? So we have dw over w minus 300 equals 1 over 25 times dt, right? So we need to take antiderivative both sides, right? So this guy can be written as antiderivative of dw minus 300 over w minus 300, right? Because when you take the derivative of this one, it's actually w, right? Equals 1 over 25 t plus c, right? Now the left hand side turns out to be ln absolute value of w minus 300 equals 1 over 25 t plus c, right? These guys come from the formula antiderivative of du over u equals ln absolute value of u plus c, so keep that in mind. Alright, now initial condition right here is w equals 1400, which is greater than 300, right? So I'm going to subtract 300 both sides, so I have w subtract 300 greater than 0, right? So then I can remove the absolute value side without changing anything, right? So I have ln of w minus 300 equals 1 over 25 t plus c, right? So I use initial condition right here, right? So I have ln of 1400 subtract 300 equals 1 over 25 times 0 plus c, right? So it could be ln of 1100 equals c, right? Now I substitute this guy right here back to this equation right here, right? So I have ln of w minus 300 equals t over 25 plus ln of 1100, right? Now I'm going to exponentiate both sides. W minus 300 equals e to the t over 25 times e to the ln 1100, right? So it could be w minus 300 equals e to the t over 25 times 1100, right? Now I'm gonna add 300 both sides, so w equals 1100 times e to the t over 25 plus 300, right? For t between 0 and 20, right? This one is the final answer. Now let's move on to question 9. Let R be the region enclosed by the graph of f(s) equals s to the 4 minus 2.3 s cubed plus 4 and the horizontal line y equals 4 as shown in the figure above. Question A. Find the volume of the solid generated when R is rotated about the horizontal line y equals -2. Now y equals -2 is going to be right here. Alright, so this one is axis of revolution, right? So the volume equals, now when you rotate the region R about this line right here, we're gonna create the solid that its volume will be calculated using the washer method, right? Because you have the hole, right? So the inner radius is right here, and the outer radius is right here, right? The inner radius changes depending on the function f of s right here, right? And the outer radius remains unchanged, right? This one's y equals 4, right? So the volume is the integral from 0 to this guy right here, right? So we need to find the intersection between this guy and this guy, right? Now we need to bring up the calculator. Add graphs right here. The first one, we need to input the function f(s) right here. And the second one, y equals 4. So you're gonna hit tab, hit 4, press enter. It's gonna be right here, right? Now we need to find the intersection right here, right? So we're gonna press menu, number 6, number 4, go to the left, go to the right. It's gonna be 2.3, right? So we have the integral from 0 to 2.3, right? Don't forget to put pi in the front, right? The outer radius is the difference between 4 and -2 right here, right? So 4 minus -2, which means add 2 altogether square. Subtract the inner radius, the difference between f(s) right here and the line right here, right? So it could be s to the 4 minus 2.3 s squared plus 4, subtract -2, you're gonna add 2, right? Square and then ds. Now we're gonna print up the calculator to calculate this one. Hit calculate, copy this one down. Alright, we're gonna put pi in the front. Integral from 0 to 2. Press Ctrl Enter. It's gonna be 98.867. Now question B. Region R is the base of the solid. For this solid, its cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in the region R. Find the volume of the solid. Alright, so region R is right here. Now the cross-section is perpendicular to the x-axis and the shape is the isosceles right triangle where the leg is on the base, right? So the leg is right here. So you know that the area of the right triangle This is the right angle right here, right? This hypotenuse right here. The leg is here and the leg is right here, right? Now, the leg is the difference between y equals 4 and the function f of s right here, right? So it should be 4 subtract f of s, right? Since this one is the isosceles right triangle, so this is leg 1, this is leg 2 is still 4 minus f of s, right? So the error should be base times height divided by 2, right? So it could be 4 minus f of s altogether square, right? Divided by 2, right? The volume should be the interval from 0 to 2.3 of 4 minus f of s altogether square divided by 2 ds, right? So we're gonna print up the calculator. We're gonna copy this one down over here. The interval from 0 to 2.3 of 4 minus f of s is s to the 4 minus 2.3 s cubed plus 4, right? Divide by 2, right? So I'm going to multiply by 1/2. Press Ctrl Enter. It's going to be 3.574. Now let's move on to question C. The vertical line s equals k divides the region R into two regions with equal error. Write but do not solve an equation involving integral expression whose solution gives the value of k, right? So suppose the line s equals k is right here. So does that mean the volume of this region from 0 to k equals the volume of this region from k to 2.3, right? So we just set up two intervals, right? Equals the interval from k to 2.3 of 4 subtract f of s ds, right? Question 10. Let f of s equals 2s squared minus 6s plus 4 and g of s equals 4 cosine of 1 over 4 pi s. Let R be the region bounded by the graphs of f and g as shown in the figure above. Find the error of the region R, right? So it's going to be the interval from 0 to 2. Y top subtract y bottom, right? Y top is right here, y bottom is right here, right? 4 times 4 over pi sine of pi over 4s evaluated from 0 to 2. Subtract 2 over 3s cubed minus 3s squared plus 4s evaluated from 0 to 2. Now recall the antiderivative of cosine of as plus b ds is going to be 1 over a sine of as plus b plus c. Keep that in mind. Now we're going to substitute 2 for s, right? So 4 times 4 equals 16. So 16 pi times. Substitute 2 over here. We have sine of pi over 2. Subtract sine of 0. Subtract. Substitute 2 over here. It could be 8. 8 times 2. It could be 16. So 16 over 3 minus 12 plus 8. And then substitute 0. It could be 0, right? Now, sine pi over 2 equals 1. This one equals 0. So it could be 16 over pi. Subtract 16 over 3 plus 12 subtract 8. So the final answer should be 16 over pi minus 4 over 3, right? Question B. Right, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 4. Now this slide y equals 4. The inner radius is the distance from here to here, right? The outer radius is the distance from here to here, right? So the volume equals integral from 0 to 2. Don't forget pi right here. The outer radius square subtract the inner radius square, right? Outer radius is difference between y equals 4 and the function f of s right here, right? So we have 4 subtract f of s altogether square subtract the inner radius, the difference between y equals 4 and the function g of s right here, right? It's going to be right here. So it could be 4 subtract g of s altogether square ds. Now let's move on to question C. The region R is the base of a solid. For this solid, its cross-section perpendicular to the x-axis is a square. Right, but do not evaluate an integral expression that gives the volume of the solid, right? So, the cross-section is something like this. The side length is the difference between the top function and the bottom function right here, right? So you know that the volume of the solid using the cross-section is going to be the integral from 0 to 2 of a of s ds, right? Because the cross-section is perpendicular to the axis right here, right? So it could be integral from 0 to 2. The sine square, but the sine is the difference between top and bottom right here. Top is the cosine function, right? So it could be g of s subtract bottom, which means f of s, right? And then square, right? Because this is the area of the square, ds. Now let's move on to question 11. The function f and g is given by f of s equals square root of s and g of s equals 6 minus s. Let R be the region bounded by the x-axis. The graphs of f and g as shown in the figure above. Find the area of the region R. Alright, so we need to separate this one into two sections, right? So the integral from 0 to 4, the top is this guy, and the integral from 4 to 6, the top is this guy, right? So the area of the region R is the integral from 0 to 4 of f of s subtract y equals 0 right here, right? So it could be square root of s ds plus the integral from 4 to 6 of this one, right? So this guy actually the right triangle, right? So it's going to be base equal 2 times height equals 2, right? So plus 2 times 2 divided by 2, right? So it's going to be 2 over 3s power of 3 over 2 evaluated from 0 to 4 plus 2. So it could be 22 over 3. Now question B. The region R is the base of a solid. For each y, where y between 0 and 2, the cross-section of the solid taken perpendicular to the y-axis is a rectangle, whose base lies in the region R and whose height is 2y. Right, but do not evaluate an integral expression that gives the volume of the solid. Alright, so we go back over here. The base is right here. We need to rewrite the function f of s and g of s in terms of y, because the cross-section perpendicular to the y-axis, every single thing must be in terms of y, right? So f of s equals square root of s. We have y equals square root of s, square both sides, so it could be s equals y squared, right? Now for this one right here, y equals 6 minus s, then s equals 6 minus y, right? And this is right, this is left, right? So the volume equals the interval from 0 to 2 right here, right? Of a of y dy, right? So cái be interval from 0 to 2. The base of the rectangle is the difference between g of s and f of s, right? So we have g of s is going to be 6 minus y right here. So 6 minus y subtract f of s is going to be y squared right here, right? dy. The height is 2y, right? Now let's move on to question 12. Let R be the region in the first quadrant enclosed by the graphs of y equals 2s and y equals s squared as shown in the figure above. Find the area of the region R. Alright, so we have A equals the interval from 0 to 2, right? Y top subtract y bottom. Y top is the linear function right here, which is 2s, right? Y bottom is s squared ds, right? So it's going to be s squared minus 1 over 3s cubed evaluated from 0 to 2, right? So it could be 4 minus 8 over 3, right? It could be 4 over 3. Now question B. The region R is the base of a solid. For this solid HHS, the cross-section perpendicular to the axis has an area A of s equals sine pi over 2s. Find the volume of this solid. So it could be V equals the interval from 0 to 2 because the cross-section perpendicular to that axis, right? So we're going to use the left and the right end bound, right? Of A of S ds, right? So it could be interval from 0 to 2 sine of pi over 2 s ds. So it's going to be negative 2 over pi of cosine of pi over 2 s evaluated from 0 to 2, right? Remember you have antiderivative of sine of as plus b ds is going to be negative 1 over a cosine of as plus b plus c, right? So we substitute 2 per s is going to be negative 2 over pi subtract cosine of 0, right? Now cosine of pi equals negative 1, so it could be negative 2 over pi times negative 1. Cosine of 0 equals 1, so it could be minus 1. So the answer is 4 over pi. Now question C. Another solid has the same base R. For this solid, the cross-section perpendicular to the y-axis are square, right? But do not evaluate an inverse expression for the volume of the solid, right? So we have the cross-section perpendicular to the y-axis, so it should be in terms of y, right? So we're gonna go back over here. The cross-section right here is a square, right? So it could be something like this, right? So V equals the interval from 0 to 4 right here, right? The sine of the square is the difference between the function y equals s squared and y equals 2s right here, right? Now we need to rewrite two functions right here in terms of y, right? So we have s squared equals y. Take square root both sides, so it can be s equals plus and minus square root of y, right? So we're going to pick the positive one because it's on the first quadrant, right? Now this one right here, y equals 2s, right? So s equals y divided by 2, right? So it's going to be square root of y subtract y divided by 2. And the error of the square equals sine times sine, right? So it could be this one square dy, right? Now let's move on to question 13. Let R be the region bounded by the graph of y equals sine pi s and y equals s cubed minus 4s as shown in the figure above. Alright, so this one actually is y equals pi s and this one's y equals s cubed minus 4s, right? Now find the error of the region R, right? So it could be the error of the region R equals the interval from 0 to 2. Y top subtract y bottom, right? So it could be sine of pi s subtract s cubed minus 4s ds, right? Now since we are allowed to use the calculator, so we're going to bring up the calculator. So I'm going to store the function sine pi s first, right? Hit control and the button right here, put sine of pi s, press enter. Now second one, I'm going to store the function g of s. So I press g of s, press control and the button right here, input s cube minus 4s, press enter, right? So now I just hit the button right here, input the interval right here, interval from 0 to 2 of enter, it's gonna be 4. Question B. The horizontal line y equals -2 splits the region R into two parts. Write but do not evaluate an interval expression for the error of the part of the region R that is below this horizontal line, right? So y equals -2 is gonna be right here. So we need to calculate the error of this one right here, right? Now we need to find the intersection between this guy and this guy, right? So we need to use the calculator, right? Hit add graphs right here, input the function fs, press enter, it's gonna be right here. And the line y equals -2, so press tab, put -2, press enter, it's gonna be right here. Now we need to find the intersection right here, right? So we're gonna press menu, number set, number 4, go to the left, go to the right, it's gonna be 0.539, and menu number set number 4, go to the left, go to the right, it's gonna be 1.68, right? So your error should be the interval from 0.539 to 1.68. The top subtract the bottom, right? Now question C. The region R is the base of a solid. For this solid, its cross-section perpendicular to the x-axis is an equilateral triangle. Find the volume of this solid, right? The cross-section is the equilateral triangle, right? Now we need to find the side length of the equilateral triangle first, right? So the length equals the difference between this guy and this guy, right? So it could be sine pi s subtract s cubed plus 4s, right? And you know that the error of the equilateral triangle is going to be square root of 3 over 4 times the sine square, right? So the error should be this guy right here, square, right, times √3 divided by 4. The volume should be the interval from 0 to 2 of this guy, right? Now we're gonna bring up the calculator. Go to home screen, hit calculate. Now previously we store function fs and gos right here, right? So we just use this right here. We put √3 over 4 in the front. So hit this button, put a fraction right here. Then the interval from 0 to 2 of f(s) subtract g of s, right? f(s) is sine of pi s right here. Then don't forget to put square outside. Then press Ctrl Enter. It's gonna be 4.321. Now let's move on to the last one, question D. The region R models the surface of a small pond. At all points in the region R at a distance s from the y-axis, the depth of the water is given by h of s equals 3 minus s. Find the volume of water in the pond, right? Alright, so let's sketch the rectangle. It's gonna be like this. Alright, so this is the depth, right? The depth equals 3 minus s, right? And the length is the difference between this guy and this guy, right? So basically, the cross section is the rectangle. So the length is still this guy right here. So the volume should be the interval from 0 to 2, right? Of 3 minus s times sine pi s minus s cubed plus 4s ds, right? Print up the calculator. Right here you just put 3 minus s and remove the square right here. And then press Ctrl Enter. It's gonna be 8.369. Question 13. The temperature of water in a tub at time t is modeled by a strictly increasing twice differentiable function W, where Wt is measured in degrees Fahrenheit and T is measured in minutes. At time t equals 0, the temperature of the water is 55 degrees. The water is heated for 30 minutes, beginning at time t equals 0. Value of Wt at selected times t for the first 20 minutes given in the table above. Use the data in the table to estimate W prime of 12. So we see that 12 is between 9 and 15, right? So we're going to use the mean value theorem, right? So it's going to be W prime of 12 equals W 15 subtract W of 9 over 15 subtract 9, right? For the mean value theorem say f prime of C equals f of B minus f of A over B minus A, where C is inside the interval A and B, right? So it's gonna be W of 15 equals 67.9 subtract W of 9 equals 61.8 over 6, right? Alright, so we have 67.9 subtract 61.8. Press enter. Then you divide by 6. Press enter. It's gonna be 1.0167, right? So we need to say the water temperature is increasing at a rate of approximately 1.0167 degrees Fahrenheit per minute at time t equals 12 minutes, right? Now question B. Use the data in the table to evaluate the interval from 0 to 20 of W prime of t dt. Alright, so we're going to use the fundamental theorem of calculus, right? So we have the interval from 0 to 20 of W prime of t dt. It's going to be W of 20 subtract W of 0, right? So we're going to use the table right here. W of 20 equals 71, W of 0 equals 55, right? So we have 71 subtract 55, right? So it could be 16, right? So we need to say the water has warmed by 16 degrees Fahrenheit over the interval from t equals 0 to t equals 20, right? Now let's move on to question C. For t between 0 and 20, the average temperature of the water in the tub is this guy. Use a lab remain sum with 4 subintervals indicated by the data in the table to approximate this guy. Alright. So we have 1 over 20, the interval from 0 to 20, W of t dt is 1 over 20 times. Okay. Alright, we're going to use the left remain sum with 4 subintervals, right? The first interval right here, the width is 4, right? Second one, the width is 5. Third one, 6, and the last one, 5, right? And since we use the left remain sum, we need to use the height right here on the left, right? This guy, this guy, this guy, and this guy only, right? So it should be 55 times 4 plus 57.1 times 5 plus 61.8 times 6 plus 67.9 times 5, right? Now we're going to put this one on the calculator and then press Ctrl Enter. It's going to be 60.79. Now, does this approximation overestimate or underestimate the average temperatures of the water over these 20 minutes? Alright, so first we need to know that if the function is increasing or decreasing. So we look at this one right here. The function is strictly increasing, right? So when you use the left remain sum for the strictly increasing function, the approximation is an underestimate. Now let's move on to question D. For t between 20 and 25, the function w that models the water temperatures has first derivative given by this guy. Based on this model, what is the temperature of the water at times t equals 25? Alright, so we're going to use the fundamental theorem of calculus, right? So the final amount W of 25 equals the initial amount W of 20 plus the interval from 20 to 25 of W prime of t, which is 0.4 square root of t cosine of 0.06 t, right? W of 20 is given by this number right here, right? 71, right? So we're going to bring up the calculator. Right, so we have 71 plus, hit the put on right here, input the interval from 20 to 25 of 0.4 times square root of x times cosine of 0.06 x dx. Press Ctrl Enter. It's going to be 73.043, right? Now let's move on to question 14. Let f and g be the function defined by f of s equal 1 plus s plus e to the s squared minus 2s and g of s equal s to the 4 minus 6.5 s squared plus 6s plus 2. Question A. Find the sum of the errors of the regions R and S, right? So we see that the two regions right here intersect at this point right here, right? Now we need to graph these two guys on the graphing calculator, right? So we're gonna press home screen, go to graph, hit tab, go to F1 right here. Alright, now input this function, right? Alright, press enter. Now the second one, press tab, go to F2. Now input this function, right? And then press enter. Alright, now we need to adjust the window so that we're going to see the function, right? Menu, window, and window setting right here. -10 for S minimum as maximum 10, right? For this one right here, negative 10, and for this one right here, 10, and then press OK. It's gonna be right here. Now we need to find the intersection right here, right? So we need to press menu, number, set number 4, go to the left, go to the right. It's gonna be 1.03, right? Alright, so we have area equals the interval from 0 to 1.03, right? Within this interval, that's the region R. The function g of s is above the function f of s, right? So it should be g of s subtract f of s all together ds, right? Plus the interval from 1.03, right? To within this interval, that is the region S, right? F of S is above G of S, right? So it should be F of S subtract G of S ds, right? So we're gonna print up the calculator. Now the faster way to do this one is to store the function F of S and G of S, right? So you're gonna go to home screen, hit calculate. Now you need to hit F of S, press Control and the button right here. Input the function F of S, then press Enter. Now you do exactly the same thing for the function g of s. You're gonna hit the button right here, pick the interval from 0 to 1.03, right? Parenthesis g of s subtract f of s. Plus the interval from 1.03 to 2, f of s subtract g of s, right? Control Enter. It's gonna be 2.0043. Now question B. Region S is the base of a solid whose cross-sections perpendicular to the x-axis are square. Find the volume of the solid. Alright, so region S is right here. Alright, you need to find the side length of the cross-section. So here's the cross-section, right? And the side length is right here. Right? Difference between f of s and g of s, right? So we have the side length equals f of s subtract g of s, right? So you know that the volume is going to be the interval from 1.03, right? Because the cross section is perpendicular to that axis, right? So it could be 1.0322 of f of s subtract g of s square, right? Because the error of the square equals sine times sine, right? This guy and this guy should be the same, right? ds, right? So we're gonna print up the calculator. Alright, I have it right here. I just copy this one down over here. And then press Control Enter. It's gonna be 1.283, right? Now let's move on to question C. Let h be the vertical distance between the graphs of f and g in the region S. Find the rate at which h changes with respect to s when s equals 1.8. Alright, so h of s equals f of s subtract g of s, right? Now when it's come to the rate, we need to find the derivative of this one, right? So it could be f prime of s subtract g prime of s, right? And then we need to calculate the rate at 1.8, right? So h prime of 1.8 equals f prime of 1.8 minus g prime of 1.8, right? So we're gonna print up the calculator. Now previously we stored the function f of s and g of s, so it's very convenient, right? So we just hit menu number 4, number 2, right? The variable is s, right? The value should be 1.8. Press OK, right? Derivative of what? F prime of 1.8, right? So you need to hit f of s, right? subtract G of S, and then press Ctrl Enter. It's gonna be negative 3.812, right? Now let's move on to question number 15. Grass clippings are placed in a bin where they decompose for t between 0 to 30. The amount of grass clippings remaining in the bin is multiplied by A of t equals this guy, where A of t is measured in pounds and t is measured in days. Question A. Find the average rate of change of A of t over the interval 0 to 30. Alright, so remember average rate of change is given by the formula f of b minus f of a over b minus a, right? So we have a of 30 subtract a of 0 over 30 subtract 0, right? A right here, b right here. Now you're gonna store the function a of t first, right? So I have a of t. Press Ctrl and D, put it right here. 6.687 times 0.931 raised to the t. Press Enter. Now we're gonna hit the, put it right here, input the fraction. Alright, so it should be a of 30 subtract a of 0 over 30 subtract 0, which means 30, right? Press Ctrl Enter. It's gonna be negative 0.197, right? Now question B. Find the value of a prime of 15. Alright, so we're gonna print up the calculator. Now since you already store the function, right? Press menu, calculus, derivative at the point right here. The variable should be s, the value should be 15, right? And then press OK. Now you input the function a of t, Ctrl Enter. It's gonna be negative 0.164. Now, using correct units, interpret the meaning of the value in the context of the problem. Alright, so we need to say the amount of grass clippings in the bin is decreasing because you have the negative sign right here at a rate of 0.164 pounds per day at t equals 15, right? Now question C. Find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clipping in the bin over the time interval t between 0 and 30. You know that the grass clippings in the bin is given by the function a of t, right? Equals to the average amount of grass clippings, right? So you know the average formula is going to be 1 over b minus a, which means 30, right? Interval from 0 to 30 of a of t dt, right? And you solve for t, right? Now I hit tab, I go to the first function, right? So I need to put a of s, right? And then press enter. It's gonna be right here, right? Now the second function, it should be 1 over 30 and in row of this one, right? So I need to hit tab, go to the second function, delete this one, hit the, put it right here, input the fraction 1 over 30, right? And then hit the, put it right here, input the interval right here from 0 to 30, right? Of a of s, right? Press enter. You get this one right here, right? And this is the intersection. Press menu number 6, number 4. Go to the left, go to the right. The answer is 12.4. Now question D. For t greater than 30, L of t, the linear approximation to a at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use LT to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. L of t is the linear approximation to A, right? So you need to calculate A prime of t, right? And you need to evaluate A prime of 30, right? At t equals 30 to get the slope, right? And you need to calculate A of 30, right? To find the coordinate of S and Y, right? Where S is 30 and Y should be A of 30, right? So you're going to use the point slope formula Y minus Y1 equals the slope times S minus S1, right? So Y1 is right here, right? So we have, and Y actually L of t, right? So you have L of t minus A of 30 equals the slope is going to be A prime of 30 times S in this situation should be t, right? Because we're going to use the time t, right? Subtract S1. S1 is 30 right here. Finally, L of t equals A prime of 30 times t minus 30 plus A of 30, right? Alright, now we're going to bring up the calculator. We need to calculate A prime of 30, right? So we need to hit menu calculus derivative at a point, the variable as the value 30. Press OK. Input the function A of S and then press enter. It's going to be negative 0.0559, right? Times t minus 30 plus A of 30. So you're going to print up the calculator, hit A of 30. Press Ctrl Enter. It could be 0.783, right? Now 0.5 pounds of grass clippings right here, actually LT, right? So we let this one equals 0.5, right? Now we're gonna grab these two guys on the calculator and we're gonna find the intersection. That is our answer, right? So we're gonna go to home screen, hit graph, hit tab, go to the first function. It should be, then press enter. Now the second function, hit tab, go up, clear this one. It should be 0.5, right? Press enter. Alright, so here's the intersection. Press menu, number 6, number 4, go to the left, go to the right. The answer is 35.1. Let's move on to question 1. On a certain work day, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine t squared over 18, where t is measured in hours and t between 0 to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, t between 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. Question A. Find G prime of phi. We're gonna bring up the calculator. Hit add calculator. Now first you need to store the function, right? So you're gonna hit G of t. Press Ctrl and the button right here. Input the function right here. 90 plus 45 times cosine of t squared over 18. Hit the button right here, input the fraction. t squared over 18. Press enter. Alright, now we need to calculate GPRAM of 5. So you're gonna press menu calculus number 2. The variable is t. The value is 5. Press OK. And then you just input g of t. Press Ctrl Enter. It's gonna be negative 24.587. Now, using the correct units, interpret your answer in the context of the problem. So, we need to say the rate at which gravel is arriving is decreasing, because you see the negative side right here, by 24.587 tons per hour square at time t equals 5 hours. Now question B. Find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Alright, so you know that this function is the rate, right? So in order to find the total amount, you need to calculate the interval from 0 to 8, right? Because t greater than or equal to 0, less than or equal to 8, right? Of g of t dt, right? So we're gonna print up the calculator. Previously, we already stored the function g of t, so it's really convenient, right? We just hit the button right here, input the interval, and it's gonna be from 0 to 8. Hit input g of t and then dt. Press Ctrl Enter. It's gonna be 825.551, right? Now let's move on to question C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Now, the rate at which unprocessed gravels arrives is given by this function, right? During the hours of operation, the plant processes gravel at a constant rate, 100 tons per hour, right? So we need to calculate g of 5, right? And we're going to compare this amount with this amount, right? So I'm going to calculate g of 5, right? I'm going to print up the calculator, press g of 5, press Ctrl Enter. It's going to be 98.140, right? This amount less than 100, right? So we need to say the rate at which unprocessed gravel is arriving is less than the rate at which it is being processed. Therefore, the amount of unprocessed gravel at the plant is decreasing at t equals 5 hours. Now let's move on to question D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation, which means 0 less than or equal to t less than or equal to 8 on this work day. Alright, so when it comes to minimum, maximum, increasing or decreasing, think about the first derivative, right? So I know that the function a of t equals initial amount right here is going to be 500 tons, and rate in is right here, right? Rate out is right here, right? So we have a of t equals 500 plus the interval from 0 to t of g of s minus 100 altogether ds, right? Now we're gonna check the derivative of this one. A prime of t equals derivative of this one is 0. Derivative of this one you just substitute t. Then we need to let this one equals 0 to find the critical numbers, right? So we have a prime of t equals 0 is the same thing as g of t equals 100, right? So we're gonna print up the calculator and then press enter. Now, since we don't see the graph, we need to adjust the window, right? Go to menu number 4. Right, now we're gonna press tab, input the second function, it's gonna be 100. Press enter, it's gonna be right here. Now the intersection is right here. We just press menu number 6, number 4. Go to the left, go to the right. The answer is 4.92. Now, since we have the closed interval, right? So we need to use the candidate test. Alright, when t equals 0, substitute 0 for t over here. This guy equals 0, we only have 500, right? Now, when t equals 4.92, substitute 4.92 for t over here, right? And then we're going to print up the calculator. Press Add Calculator. Hit this button right here, input this interval, right? It's going to be from 0 to 4.92 of 90 plus 45 times cosine of minus 100 ds, and don't forget to add 500. Press Ctrl Enter. It's gonna be 635.375. Now when t equals 8, I'm gonna copy this one down over here. I just replace 4.92 with 8. Then I'm gonna press Ctrl Enter. It's gonna be 525.551. Now you need the maximum amount, right? So it could be right here at t equals 4.92, right? So you need to say that the maximum amount of unprocessed gravel at the plant during this workday is 635.375 tons. Now let's move on to question 2. A particle moves along a straight line for t between 0 and 5. The velocity of the particle is given by v of t equals this guy, and the position of the particle is given by s of t. It's known that s of 0 equals 10. Question C. Find all times t in the interval t between 0 and 5, at which the particle changes direction. Now, in order to know if the particle changes direction, we need to find the critical number of v of t, right? So we let v of t equals 0, right? Hit graph right here, hit tab, go to the function 1 right here, clear this one. We need to input negative 2, press enter. It's gonna be right here. So we're gonna restrict the domain, press menu number 4, number 1, s minimum 0, s maximum 5, press OK. It's gonna be right here. So we have 2 zeros right here, right? So we need to press menu number 6, number 1. Go to the left, go to the right. We have the first 0 right here. Now menu number 6, number 1. Go to the left, go to the right. We have the second 0 right here, right? We need to create a side chart, right? Now we're gonna test the interval, right? So I'm gonna pick 1 in this interval, right? Substitute 1 for t into the function right here. It's gonna be 2.278. It's gonna be positive, right? So this interval is positive and you keep changing the size. So this one should be negative. and this guy should be negative, right? The particle changes direction when v of t changes sign, right? So v of t changes sign at this guy right here because it goes from negative to positive, and right here from positive to negative, right? Now let's move on to question D. Is the speed of the particle increasing or decreasing at time t equals 4? Alright, so if the speed of the particle is increasing, you have v of t times a of t greater than 0, right? In other words, they both have the same sign, right? If the speed of the particle decreasing, v of t times a of t less than 0, or they have the opposite sign, right? So I'm going to bring up the calculator. I need to calculate a of t, right? So I need to store the function v of t first, right? So v of s, press Ctrl the button right here, escape, then press enter. Now we need to calculate a of s when s equals 4, right? So we're gonna press menu number 4, number 2 right here, derivative at a point. The variable is s, the value should be 4. Press OK. Now we just input v of s and then press Ctrl enter. It's gonna be negative 22.295, right? And we need to calculate v of 4, right? So we just press v of 4, press Ctrl enter. It's gonna be negative 11.475. Now observe that a of 4 and v of 4 have the same sign. Then we need to say the speed of the particle is increasing. Now let's move on to question 3. Joanna jogs along a straight path for t between 0 and 40. Joanna's velocity is given by a differentiable function v. Selected values of v of t where t is measured in minutes and v of t is measured in meters per minute, given in the table above. Question B. Using correct units, explain the meaning of the definite interval. The interval from 0 to 40 of absolute value of v of t dt in the context of the problem. Approximate the value of this one using the right remain sum with the 4 subintervals indicated in the table. Alright, so this guy right here, actually the total distance Joanna is jogging in meters over the time interval 0 to 40, right? Now, to calculate this one using the right remain sum, so we have the interval from 0 to 40 of absolute value of v of t dt is, the width of this one is 12, right? This guy is 8, this guy is 4, and this guy is 16, right? The right remain sum, so we need to use this one as the height, right? So we have 12 times absolute value of v of 12, right? Plus 8 times absolute value of v of 20, plus 4 times absolute value of v of 24, plus 16 times absolute value of v of 40. Now we're going to substitute values 12 times 200 plus 8 times 240 plus 4 times 220 because you take absolute value of this number, right? Plus 16 times 150. It's going to be 7600 meters. Question 4. The figure shows the graph of f', the derivative of the choice differentiable function f on the interval negative 3 to 4. The graph f' has horizontal tangents at s equals negative 1, s equals 1, and s equals 3. The area of the regions bounded by the x-axis and the graph f prime on the interval -2 to 1, 1, 4, and 9 and 12 respectively. Question A. Find all s coordinates at which the function f has a relative maximum. Alright, so first we need to find the critical numbers of f prime, right? So we have the critical number right here, -2, 1, and 4, right? But we need to exclude 1, right? Because right at 1, the sign doesn't change, right? It's still negative and negative, right? Right at -2, the sign changes from positive to negative, right? The function f of s is increasing, then decreasing, right? This one is the relative maximum. Question B. On what open intervals contained in -3 to 4 is the graph of f both concave down and decreasing? Alright, so when the function f concave down, it tells us that f double prime of s less than 0, right? If f double prime of s less than 0, it tells us that the function f prime of s is decreasing. Now, the function f is decreasing. It tells us that f prime of s less than 0, right? Now, if f prime of s less than 0, it tells us that the function f prime of s is below the axis. F prime of s is decreasing, which means it's going down like this. And f prime of s is below the axis, right? So we're gonna go over here. Decreasing and below the axis should be this guy right here. And this guy right here, right? So it should be from -2 to -1. And 1, 2, 3, right? Now question C. Find the s coordinates of all points of inflection for the graph of f. The function f prime changes from decreasing to increasing at s equals -1 and 3, right? Because it changes from decreasing to increasing. Now, another point of inflection is right at s equals 1 because f prime changes from increasing to decreasing at s equals 1. Question D. Given that f of 1 equals 3, write an expression for f of s that involves an interval. Find f of 4 and f of -2. Alright, so we know that this one is the initial amount, right? So the final amount should be f of s equals initial amount should be f of 1 plus the interval from 1 to ask f prime of t dt, right? So it's gonna be f of s equals f of 1 equals 3 right here. It could be 3 plus interval from 1 to s of f prime of t dt, right? So we have f of 4. It's gonna be the final amount. It's gonna be initial amount should be 3 plus the interval from 1 to 4 of f prime of t dt, right? So it's gonna be 3 plus this guy actually the error under the curve from 1 to 4 of f prime of t, right? So we look at f prime of t right here from 1 to 4, which is this guy right here, right? Given right here 12, right? But this guy is below the axis, so it should be -12, right? 3 plus -12, and it's going to be -9. Now f of -2, it's going to be 3 plus the interval from 1 to -2 of f prime of t dt, right? So it's going to be 3 minus the interval from -2 to 1, right? f prime of t dt, right? So it could be 3 minus. Now, the interval from negative 2 to 1. It's going to be given right here. It's going to be 9, right? Negative 2 to 1 is going to be right here. So again, this one is below the axis, so it should be negative 9, right? So we have 3 minus negative 9, and it's going to be 12, right? Now let's move on to question 5. Consider the differential equation dy over dx equals 1/2 x plus y minus 1. Question A. On the axis provided, sketch a slope field for the given differential equation at the 9 points indicated, right? So I'm going to start from here. It could be 0, 0, right? So I have dy over dx at x equals 0, y equals 0, right? Substitute 0, 0 for x and y over here. It could be negative 1, right? Negative 1 can be written as negative 1 over 1, right? So right at this point right here, I'm going to go to the left 1, right? And then go up 1, right? So it could be something like this. Next one, I'm going to check this point right here. So dy over dx at x equals 0, y equals 1, right? So it's going to be 0, right? So it should be the horizontal, right? Remember the Christmas tree trick. The line is going up, the slope is positive. Line is going down, slope is negative. The line is horizontal, slope is 0, and the line is vertical, the slope is undefined, right? Now I'm going to check this point right here. X equals 0, y equals 2. So it's going to be 1, right? And it's going to be 1 over 1, right? So I'm going to go up 1 and then go to the right 1, right? So it could be something like this. I'm going to check this point right here. So dy over dx when x equals negative 1, y equals 2, right? So I substitute over here, I get negative 1/2 plus 1. It's going to be 1/2, right? Alright, so I'm going to go up 1, go to the right 2, right? So it could be something like this. I'm going to check this point right here. Dy over dx at x equals negative 1, y equals 1. So it's going to be negative 1 over 2. So right at this point, I'm going to go down 1, go to the right 2, right? So it could be something like this. Now, this point right here, x equals negative 1, y equals 0, right? So it could be negative 3.5. I'm going to go up by 3. 1, 2, and 3. And then I'm going to go to the left by 2, right? 1, 2. So it could be something like this. Now I'm going to check this point right here. It's going to be negative 1 over 2, right? So it's going to be same thing as this guy right here, right? So it's going to be right here. This guy is exactly the same thing. Now I'm going to check this point right here. I have 1/2, right? This guy right here and this guy right here, same, right? Negative 1, 2. So it could be like this. And I check this point right here. So it could be 1, 2. It should be 3 over 2, right? So I'm going to go up by 3, go to the right by 2. Or I'm going to go down by 3, go to the left by 2, right? So it could be something like this. Now I'm going to erase the dotted line. Now question B. Find the second derivative of this one in terms of x and y. Describe the region in the x and y plane in which all solution curves to the differential equation are concave up. Alright. So we have the second derivative of this one. It's going to be this guy right here, take the first derivative of this one. So it's going to be 1 over 2, right? Plus this guy right here should be dy over ds, right? And this one right here equals 0, right? But dy over ds is this one, right? So 1/2 plus 1/2 x plus y minus 1. I'm going to simplify. So it's going to be 1 over 2x plus y minus 1/2, right? Now, the second derivative must be greater than 0, right? So if this one greater than 0, this guy must be greater than 0, right? We need to sketch this one right here. We're going to pick 0, 0 over here. Substitute over here, we have y equals 0 greater than negative 1/2 times 0 is going to be 0 plus 1 over 2, right? So it's going to be 0 greater than 1 over 2, which is false, right? We need to say the opposite regions, right? So it should be this region right here. So solution to this inequality should be above the line y equals negative 1/2 s plus 1/2. Now let's move on to question C. Let y equals fs be a particular solution to the differential equation with initial condition f of 0 equals 1. Thus the function f has a relative minimum, maximum, or neither at s equals 0. When it comes to minimum, maximum, we need to think about the first derivative, right? So we have the first derivative right here, right? And we need to evaluate this one at s equals 0, y equals 1 right here, right? So it's going to be 0, right? 0 is a critical number, right? Now we need to use the second derivative test, right? So we have, now we're going to take derivative of this one. It's going to be 1 over 2 plus dy over ds, right? But dy over ds equals 0 right here. So it could be 1/2, right? 1/2 is greater than 0. Since the second derivative is positive, the function f has a relative minimum at this point, right? Question D. Find the values of the constant m and b for which y equals ms plus b is a solution to the differential equation. Alright, so we have dy over ds equals 1/2 s plus y minus 1, right? Now we're going to take the derivative of this one with respect to s, right? So we have dy over ds equals m, right? So we just equate this guy and this guy, right? So we have 1 over 2 s plus y minus 1 equals m, right? But y equals ms plus b, right? So we have 1/2 s plus ms plus b minus 1 equals m, right? Now I'm a factor s out, so I have 1/2 plus m times s plus b minus 1. I subtract m both sides. It's going to be 0, right? Now 0 right here, I can rewrite this one as 0s plus 0, right? So I have a system of equation, right? You just equate the coefficient. This guy is the same thing as this guy. This guy is the same thing as this guy, right? So m equals negative 1/2, right? Substitute negative 1/2 over here. I have b equals 1/2, right? Now let's move on to question 6. We know that this guy right here is rate in, right? The domain is from 0 to 8. And this one right here is rate out. And the initial amount is 30 cubic feet of water. Right now, question 8. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval. Alright, so basically this one is rate in, right? We need to calculate the interval from 0 to 8 of rate in right here, right? dt, right? So we're gonna print up the calculator. Now we have A, B, C, and D. The best way for you to do this one is to store the function, right? So I'm gonna store the function R of t, right? You're gonna hit the button right here, input the interval from 0 to 8 of R of s ds, and press Ctrl Enter. It's gonna be 76.570. Now question B. Is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Alright, so since this one is rate in, this one is rate out. So we need to compare R of 3, right? And D of 3, right? Press R of 3. And then press Ctrl Enter. It's gonna be 5.086 and D of 3. Press Ctrl Enter. It's gonna be 5.4, right? R of 3 less than D of 3, right? It tells us that the amount of water in the pipe is decreasing at time t equals 3 hours. Now question C. At what time t between 0 to 8 is the amount of water in the pipe at a minimum? Alright. So I'm gonna let the amount of water given by the function A of t equals initial amount. It's gonna be 30 right here, right? And rate in is gonna be this guy, rate out is gonna be this guy, right? So it's gonna be 30 plus the interval from 0 right here to t of R of s subtract D of s, right? ds. Now when it's come to minimum or maximum, we need to take the derivative, right? So we have a prime of t equal derivative of this one is 0, right? For this one we just substitute over here. So we have R of t subtract D of t, right? So we need to let a prime of t equals 0 is the same thing as R of t equals D of t, right? And we need to find the intersection between these two guys, right? So we're gonna print up the calculator. Alright, previously we already saw function R of s, D of s, and it's really convenient, right? Now we just go to home screen, hit graph right here, go to tab, go up. Now we need to clear this one. Just input R of s, that's it. Press Enter. We get this one right here. Now the second one, hit tab, it's gonna be D of s. Press Enter. It's gonna be right here, right? So we need to find the intersection right here. So we need to press menu, number, set number 4. Go to the left, go to the right. The answer is 3.27, right? Now since this one is the closed interval, we need to use the candidate test, right? So if t equals 0, substitute 0 for t over here, we get 30, right? T equals 3.27, substitute over here. We have 30 plus the interval from 0 to 3.27 of R of s subtract D of s ds is gonna be 27.94. And when t equals 8, we're gonna print up the calculator, copy this one down over here. Just change the upper bound to 8. Press Ctrl Enter. It's gonna be 48.543. Now we need the minimum amount. So the minimum is right here at t equals 3.27, right? So we need to say the amount of water in the pipe is a minimum at t equals 3.27 hours. Question D. The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rate until the pipe begins to overflow. Write but do not solve an equation involving one or more intervals that gives the time W when the pipe will begin to overflow. Initial amount is 30, right? Plus the interval from 0 to W, right? It's right here. Of rate in is going to be R of T. Subtract rate out is going to be D of T dt, right? And it's going to be equals 50. That's it, right? Now let's move on to question 23. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate multiplied by FT equals 70 e to the cosine t cubic feet per hour, where t is measured in hours since midnight. Janet starts removing snow at 6 a.m., which means t equals 6, so 9 a.m. t equals 9, right? And midnight t equals 0, right? The rate t of t in cubic feet per hour at which Janet removes snow from the driveway at the time t hours after midnight is multiplied by this piecewise function. Question C. Let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain from 0 to 9. From 0 less than t less than equal to 6, then we have h of t equals the initial amount h of 0 plus the interval from 0 to t of g of s ds, right? And h of 0 equals 0 plus the interval from 0 to t, right? Within this interval, the value is 0, right? So it could be 0 ds, and the answer must be 0. Now, the second interval is going to be from 6 to 7, right? So, h of t equals h of 6 plus the interval from 6 to t g of s ds, right? 0 plus the interval from 6 to t of 125 ds, right? So it's going to be 125 s evaluated from 6 to t, right? So it's going to be 125 times t minus 6. The third interval is going to be from 7 less than t less than equal to 9. Then you have h of t equals h of 7 plus the interval from 7 to t g of s ds, right? H of 7 is going to be 125 right here, right? Plus the interval from 7 to t of 108 ds, and it's going to be 125 plus 108 s evaluated from 7 to t. It's going to be 125 plus 108 times t minus 7, right? So the piecewise function is h of t equals. Now question D. How many cubic feet of snow are on the driveway at 9 a.m., which means t equals 9, right? So you need to calculate the interval from 0 to 9, right? Of rate in subtract rate out, right? So it could be f of t dt subtract h of 9, right? So it's gonna be the interval from 0 to 9. Of this guy right here. 7t e to the cosine t dt. Subtract h of 9 is gonna be this expression right here, right? Press Control Enter. It's gonna be 26.334. Now let's move on to question 24. Let g be the function given by g of s equal 1 over square root of s. The average value of a function f on the unbounded interval a to infinity is divided by this guy. Show that the improper interval from 4 to infinity g of s ds is divergent, but the average value of g on the interval 4 to infinity is finite. We have the interval from 4 to infinity of g of s ds equals limit when b approaches infinity of the interval from 4 to b of g of s ds, but g of s equals this one. So it's gonna be limit when b approaches infinity of the interval from 4 to b of s power of negative 1/2 ds, right? So it's gonna be limit when b approaches infinity of 2 square root of s evaluated from 4 to b, right? And it's gonna be limit when b approaches infinity of 2 square root of b subtract 2 square root of 4. It's gonna be 4, right? Approaches infinity, right? Infinity subtract 4 is gonna be infinity. The interval from 4 to infinity of g of s ds is divergence. Now we need to calculate this one, right? So we have limit when b approaches infinity of the interval from a to b of f of s ds over b minus a is limit when b approaches infinity of a right here equals 4, right? So it could be 1 over b minus 4 of the interval from 4 to b of 1 over square root of s ds, right? But this guy right here has been calculated right here, right? So it could be limit when b approaches infinity of 2 square root of b minus 4 over b minus 4, right? Alright, so when b approaches infinity, this guy right here grows faster than this guy. This guy right here grows faster than this guy, right? So it's gonna be limit when b approaches infinity of 2 square root of b over b, right? Now we're gonna simplify this one, so it's gonna be limit when b approaches infinity of 2 over square root of b, right? When b approaches infinity, this guy approaches 0, right? So this one is finite. Now let's move on to question 25. The derivative of a function f is given by this guy for s greater than 0. If f of 1 equals 7, then we need to find the value of f of 3, right? So we're going to use the fundamental theorem of calculus, right? So we have f of 3 equals f of 1 plus the interval from 1 to 3 of s minus 3 e to the s, right? Now we're going to calculate this one on the side, right? So the interval from 1 to 3 of s minus 3 e to the s ds. We need to use integration by part, right? So we let u equals s minus 3, du equals ds, dv equals e to the s ds, v equals e to the s, right? So this guy becomes u times v, which means this guy times this guy, right? S minus 3 times e to the s evaluated from 1 to 3 minus v du, which means this guy times this guy, interval from 1 to 3 of e to the s ds, right? It's gonna be s minus 3e to the s. Subtract the entire divisor of this one, it could be e to the s, right? All together evaluated from 1 to 3, right? So I substitute 3 for s, it could be, the first one is 0, right? The second one is negative e cubed, right? Substitute 1 for s, I get subtract negative 2e, subtract e. So it's going to be negative e cubed. This guy turns out to be negative 3e, and negative right here is positive 3e, right? So finally, f of 3 right here equals f of 1 equals 7. Plus this guy right here, 3e minus e cubed, right? This one is the final answer. Now let's move on to question 26. If dy over ds equals this guy, y equals 3, s equals 5, what is the value of s equals 5.5? Again, we're going to use fundamental theorem of calculus, right? So we have y of 5.5 equals y of 5 plus the integral from 5 to 5.5 of this guy, right? Now I'm going to calculate this one on the side. Now I'm going to factor negative sign out, so that I'm going to do complete square, right? So this guy turns out to be the integral from 5 to 5.5 ds over. In order to find the missing term right here, I'm going to take the middle term right here, 10 divided by 2 and square, right? So it could be 5 square, right? So I just literally subtract 25, right? I need to add 25. Subtract 24, right? So it's going to be 1 minus s minus 5 altogether square, right? Now I want to apply the formula antiderivative of du over square root of a square minus u square. It's going to be a sine of u over a plus c, right? Now u in this situation is s minus 5, right? A in this situation is 1, right? So the top, look at this one right here. This is u, this must be u, right? So this guy must be s minus 5, right? Derivative of ds minus 5 is going to be ds, right? So they're both the same. So now I can apply the formula right here. So it's going to be sine of s minus 5 over 1, right? Because a equals 1. Evaluated from 5 to 5.5, right? Substitute 5.5 for s, so it could be sine of 1/2, right? Substitute 5 for s, it could be sine of 0, right? Sine of 1/2 is going to be pi over 6. Sine of 0 is going to be 0. So we have y of 5.5 equals y of 5 is going to be 3 right here. Plus pi over 6, right? Now let's move on to question 27. The graph of a differentiable function f is shown for negative 3 less than equal to s less than equal to 3. The errors of the region A, B, C, D are 5, 4, 5, 3 respectively. Question D. Let h be the function defined by h of s equals this guy. Find the value of the integral from negative 2 to 1 of h of s ds. Alright, so basically this guy is the same thing as the integral from negative 2 to 1 of 3f of 2s plus 1 plus 4 ds, right? So it's going to be 3 times the integral from negative 2 to 1 of f of 2s plus 1, right? ds plus 4 the integral from negative 2 to 1 of ds, right? Now I need to calculate this one first, right? So I'm going to let u equals 2s plus 1 and du equals 2 ds, right? So ds equals 1/2 du, right? Now I need to change the new upper bound and lower bound, right? So the O1 s equals negative 2, s equals 1. Then the new one, u equals substituting negative 2 for s is going to be negative 3, right? Substitute 1 for s is going to be 3, right? So this guy becomes the integral form negative 3 to 3 of f of u du. Now I have 1/2 here, I put 1/2 in the front, right? So now I can use this graph to find the error under the curve, right? Remember this guy must be the same, right? In order to use this graph, right? So it's gonna be 1/2. The first one right here, A, is gonna be 5, right? The second one, B right here, is below that axis, it's gonna be negative 4. The third one, C right here, is gonna be 5. And the last one right here, D, is gonna be 3. So the answer is 9/2. I substitute 9/2 over here, so it could be 3 times 9/2, right? Plus 4s evaluated from negative 2 to 1, right? So it could be 27/2 plus 4 times 1 plus 2, right? So the final answer should be 51/2. Sarah wrote a stationary bicycle. The number of rotations per minute of the wheel of the stationary bicycle at time t minutes during Sarah ride is modeled by function s, defined by s of t equals this guy for t between 0 and 9 minutes. Find the average number of rotations per minute of the wheel of the stationary bicycle for t between 0 and 9 minutes. Alright, so we're going to use the average formula, right? So we have 1/b minus a. This is a, this is b, so it could be 9, right? Integral from 0 to 9 of s of t dt, right? So it could be 1/9. Integral from 0 to 9 of 40 plus 20 pi sine of pi t over 18 dt, right? So it's going to be 1/9 times 40 t, right? Now remember antiderivative of sine of a s plus b ds is going to be negative 1/a cosine of a s plus b plus c. So keep this one in mind, right? So a in this situation is pi over 18. Now you just flip this one. It's going to be 18 over pi, right? It turns out to be negative 360 cosine of pi t over 18, right? Evaluated from 0 to 9, right? So I'm going to substitute 9 for t. So it could be 1/9 times 360 subtract 9 for t over here. It's going to be cosine of pi over 2 is going to be 0, so we don't have to worry about this guy anymore, right? Substitute 0 for t, this guy equals 0, right? This guy becomes negative 360, and subtract negative 360 is going to be positive 360, right? So it could be 720/9, and it's going to be 80 rotation per minute. Now let's move on to question 29. Consider the function f given by this guy. Evaluate the integral from 0 to infinity of Ls ds. The integral from 0 to infinity of s times e to the negative 2s. Limit. When b approaches infinity of the integral from 0 to b as e to the negative 2s, right? So we're going to use integration by part, right? Let u be as du equals ds, dv equals e to the negative 2s ds, v equals negative 1/2 e to the negative 2s. Integral from 0 to b of s e to the negative 2s ds becomes u times v. This guy times this guy, right? It's going to be negative 1/2 s e to the negative 2s evaluated from 0 to b minus v du is going to be right here. So plus 1/2 integral from 0 to b of e to the negative 2s ds, right? So this guy becomes negative 1/2. Substitute b for s, so it could be b times e to the negative 2b. Substitute 0 for s, could be 0, right? Plus, now antiderivative of e to the negative 2s, it could be negative 1/2, right? So it could be negative 1 over 4 e to the negative 2s evaluated from 0 to b, right? So it's going to be negative 1 over 2b e to the negative 2b minus 1 over 4 times e to the negative 2b. E to the 0 is going to be 1, right? Now I'm going to simplify this one. So it's going to be negative b over 2 times e to the 2b, right? Distribute this one, so it will be minus 1 over 4 e to the 2b, right? Plus 1 over 4, right? Now I'm going to factor negative 1 over e to the 2b out. So it's going to be b over 2, right? Plus 1 over 4, right? Plus 1 over 4 right here, right? Now I'm going to bring this guy back over here. So I have limit when b approaches infinity of, now when b approaches infinity, this guy approaches 0, right? 0 times this guy, it could be 0. The answer is 1 over 4, right? Let's move on to question 7. Let f be the function satisfying f prime of s equals negative 3s times f of s for all real numbers s with f of 1 equals 4, right? This one is the initial condition, right? Question B. Use Euler's method starting at s equals 1 with step size 0.5 to approximate f of 2, right? So we just get the table. Alright, the initial condition is right here, s equals 1, y equals 4, right? And you know that the step size is 0.5, right? And it's going to be ending at 2, right? So we have 1.5 and we stop at 2, right? Now we need to find the slope of the equation. So we have the slope is given by this formula, right? Negative 3 times s times f of s, right? So negative 3 times 1 is going to be negative 3 times 4 is going to be negative 12, right? So equation of the tangent line is going to be y equals the slope negative 12 times s minus s1, which means 1, plus y1, which means 4, right? So we substitute 1.5 for s over here. We have negative 12 times 1.5 subtract 1 is going to be 0.5, right? Plus 4. So it's going to be negative 2. We put negative 2 over here, right? Now, new dy over ds is negative 3 times 1.5 is going to be negative 4.5 times negative 2 is going to be 9, right? So y equals 9 times s minus 1.5 subtract 2, right? So it's going to be 9 times s equals 2 right here. Subtract 1.5 is going to be 0.5 minus 2, right? So it could be 2.5, right? We put 2.5 right here. This one is the final answer. Now question 8, similar to question 7. I'm going to leave this one for you to practice, right? The answer is negative 23 over 4. Now question D. Let y equals g of x be another solution to the differential equation with initial condition g of 0 equals k, where k is a constant. Euler's method starting at s equals 0 with step size 1 gives the approximation g of 1 equals 0. Find the value of k. We're going to sketch the table. Alright, initial condition is s equals 0, y equals k. Now dy over ds, we're going to use this formula, right? So it's going to be 2k plus 1. Now equation of the tangent lines y equals 2k plus 1, right? Times s minus 0 plus y is going to be k, right? Now we start at s for 0, step size 1, right? So the final value should be this guy right here. Substitute 1 for s over here, right? So we have 2k plus 1 times 1 minus 0 plus k, and this guy actually 0 right here, right? So we just solve the equation, right? So we have 2k plus 1 plus k equals 0, right? So we have 2k plus k equal be 3k equals negative 1, right? So k equals negative 1 over 3. This one is the final answer. Now question 9. This question is similar to the previous question, right? We have two step size, right? Starting as for negative 1, so we have negative 1 over here, and then we're going to end as 0, right? So it could be negative 0.5 and 0 right here, right? I'm going to leave this one for you to practice. The answer is 17 over 4. Now let's move on to question 10. The function f is twice differentiable for s greater than 0 with f of 1 equals 15, f the program of 1 equals 20. Values of f prime, the derivative of f given for selected values of s in the table above. Question A. Write an equation for the line tangent to the graph of f as equals 1. Use this line to approximate f of 1.4, right? So we have f of s equals m times s minus s1 plus f of s1, right? S equals 1, so we have the slope, which is f prime of 1, right? But f prime of 1 is 8, right? Times s minus 1, right? Plus f of 1. F of 1 is 15 right here. So we need to calculate f of 1.4. It's going to be 8 times 1.4 subtract 1 plus 15, right? So it's going to be 8 times 0.4 plus 15, right? 8 times 0.4 is going to be 3.2 plus 15 is going to be 18.2. Now question B. Use a midpoint remain sum with two subintervals of equal length and values from the table to approximate the interval right here. Use the approximation for this guy to estimate the value of f of 1.4. So the interval from 1 to 1.4 f prime of s ds using the midpoint formula. So we look at this one right here, 1 and 1.4 right here. We have the interval right here, 0.2, right? And this guy, 0.2, right? The midpoint is right here, right? This is the s value, and the height is 10 and 13 right here, right? So we have length times width, right? The length actually f prime of 1.1 plus the width 0.2, right? Plus f prime of 1.3 times 0.2, right? Now f prime of 1.5 actually 10 times 0.2 plus f prime of 1.3 actually 13 times 0.2, and it's going to be 4.6, right? Now to calculate f of 1.4, we're going to use the fundamental theorem of calculus, right? So f of 1.4 equals the initial value is going to be f of 1 right here, right? Plus the interval from 1 to 1.4 f prime of s ds, right? So it could be 15 plus 4.6 It's going to be 19.6. Now question C. Use Euler's method starting at S1 with two steps of equal sign to approximate f of 1.4. Now we're going to sketch the table. Now we start at S1, right? The y value is 15 right here, right? We have two steps of equal sign. We end at S equal 1.4, right? So 1.4 is right here. This guy must be 1.2. Now to find the slope, we need to calculate f' of 1, right? So look at the table. F' of 1 is 8 right here. And the equation of the tangent line, it could be f of s equals 8 times s minus 1 plus 15, right? Substitute 1.2 for s, so it's going to be 8 times 0.2, it's going to be 1.6 plus 15, it could be 16.6, right? So we put 16.6 over here. Now dy over dx. So we need to calculate f' of 1.2. It's going to be right here equals 12, right? So we have f of s equals the slope equals 12 times s minus 1.2 plus 16.6. So we substitute 1.4 for s over here, right? So we have 12 times 0.2 plus 16.6, right? 19. Now let's move on to question D. Write the second degree Taylor polynomial for f about s squared 1. Alright, now we know that the Taylor polynomial expansion is given by this formula. Now since the question wants you to find the second degree only, so we stop right here, right? So we have T2 of s when s equals 1. We have f of 1, right? But f of 1 equals 15 right here, right? So we have 15 plus f prime of 1. F prime of 1 is 8 right here. Times s minus 1 plus f double prime of 1. It's going to be 20 right here. 20 divided by 2, it could be 10 times s minus 1 squared, right? So it's going to be 15 plus 8 times 1.4 subtract 1 is going to be 0.4 plus 10 times 0.4 squared, right? So it's going to be 19.8. Now let's move on to question 11. The number of moves in a national park is modeled by the function m that satisfies the logistic differential equation dm over dt equals 0.6 m times 1 minus m over 200, where t is the time in years, and m of 0 equals 50. What is the limit of m of t when t approaches infinity? So when t approaches infinity, this guy approaches L, which is carrying capacity. Carrying capacity is right here, 200. Right? The answer must be B. Now let's move on to question 12. Which of the following differential equations for a population P could model the logistic growth shown in the figure above? Alright, so observe that this figure has the carrying capacity 200, right? Now remember, we have the differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L, where L is the carrying capacity. Now look at the answer choice right here. Y in this situation is P, right? So I just replace y with p, right? So I have dp over dt equals k times p times 1 minus p over l, right? Now I'm going to expand this one, so it could be dp over dt equals kp minus a over l times p squared, right? So this formula, we're going to come up with a conclusion. A correct logistic equation must have a positive linear terms kp, right? This guy positive. A negative quadratic term, this one is negative right here, right? And level of at the carrying capacity L right here, right? So we look at the answer choice right here. We need to eliminate C, D, and E because they all have the positive quadratic term, right? Now for the first one, we need to factor P out. So we have 0.2 minus 0.001 P, right? So we're going to set this one equal to 0, right? So we have 0.2 minus 0.001 P. So it's going to be P equals 200, right? Which is the maximum value right here, right? So the answer is A. Now look at answer choice B. We factor P out, right? So we only end up with 0.1 minus 0.001 P. Set this one equals 0. So P equals 100, which is not the right one, right? So answer choice B is wrong. Now let's move on to question 13. Let K be a positive constant. Which of the following is a logistic differential equation? We know that the logistic differential equation is given by the formula dy over dt equals k times y times 1 minus y divided by l, right? So we look at the answer choice right here, only E correct, right? So this problem very simple, you just recognize the logistic differential equation, right? Now let's move on to question 14. The number of fish in a lake is modeled by the function p that satisfies the differential equation dp over dt equals 0.003 p times 1000 minus p, where t is the time in years. Which of the following could be the graph of y equals p of t, right? So basically, you just recognize the logistic growth differential equation. That's it, right? So actually, answer choice is A. Consider the logistic differential equation dy over dt equals y over 8 times 6 minus y. Let y equals f of t be the particular solution to the differential equation with f of 0 equals 8. Question A. A slope field for differential equation is given below. Sketch the possible solution curves through the point 3, 2, and 0, 8. So 3, 2 is going to be right here, right? And 0, 8 is going to be right here, right? So we just follow the flow, right? So it could be something like this. Now let's move on to question B. Use Euler's method starting at t equals 0 with two steps of equal sign to approximate f of 1, right? So we're going to sketch the table. Alright, so we're going to start with t equals 0, right? So we put 0 right here. F of 0 equals 8, right? So we have y equals 8, right? dy over dt, we're going to use the formula right here. So we substitute 8 for y over here. We have negative 2, right? Equation of the tangent line is going to be y equals the slope negative 2 times t minus 0, right? Plus y is going to be 8, right? Now we're going to stop at 1. We have two steps of equal sign. So this guy should be 0.5 and this guy should be 1, right? Substitute 0.5 for t over here. So we have negative 2 times 0.5 is going to be negative 1 plus 8 is going to be 7, right? Now put 7 over here. So dy over dt is going to be 7 over 8 times 6 minus 7 is going to be negative 7 over 8, right? So we have y equals negative 7 over 8 times t minus 0.5, right? Plus 7. Substitute 1 for t over here, so we have negative 7 over 8 times 0.5 plus 7, right? So it could be 105 over 16. This one is the final answer. 16. A population is modeled by a function p that satisfies the logistic differential equation dp over dt equals p over 5 times 1 minus p over 12. Question A. If p of 0 equals 3, what is limit of p of t when t approaches infinity? Alright, so look at this one. This guy actually dy over dt equals k times y times 1 minus y over L, right? We just match this guy up, so we have the carrying capacity is 12, which is the maximum value, right? Limit of this one when t approaches infinity is always equals carrying capacity, which is the maximum value, right? So it could be 12. This guy is still 12, right? Question B. If p of 0 equals 3, for what value of p is the population growing the fastest? Remember, the population is growing the fastest when p is half the carrying capacity. Now let's move on to question 17. A certain rumor spreads through a community at the rate dy over dt equals 2y times 1 minus y, where y is the proportion of the population that has heard the rumor at time t. Question A. What proportion of the population has heard the rumor when it's spreading the fastest? Alright, so we need to find the maximum of this function, right? So basically, I just let the function f of y equals dy over dt, and it's going to be 2y, I'm going to distribute this one, minus 2y squared, right? I need to find the first derivative of this one, f prime of y equals 2 minus 4y, right? Now I'm going to let this one equals 0, right? It's the same thing as 2 minus 4y equals 0, and then y equals 1/2, right? So the proportion is 1/2. Now question B. If at time t equals 0, 10% of people have heard the rumor, find y as a function of t. So we have dy over dt is given by 2y times 1 minus y, right? Now we're going to separate the variables, so we have dy over y times 1 minus y equals 2 dt, right? Now we're going to take antiderivative both sides. Now we're going to use fraction the competition for the left hand side. So we're going to end up with antiderivative of 1 over y plus 1 over 1 minus y altogether dy, right? Equals antiderivative of 2 dt. So it's going to be antiderivative of 1 over y dy. Now for the second one right here, I'm going to replace dy with d of 1 minus y so that I can apply the formula antiderivative of du over u is going to be ln absolute value of u plus c, right? So it's going to be negative antiderivative of d of 1 minus y over 1 minus y, right? Because when I take the derivative of this one, it's going to be negative dy. So I have negative side here, it becomes positive, so thing doesn't change at all, right? So keep that in mind, equals antiderivative of 2 dt, right? So it's going to be ln absolute value of y, right? Minus ln absolute value of 1 minus y equals 2t plus c. Now we're going to use the logarithmic property to condense this one. So it could be ln of y divided by 1 minus y, right, equals 2t plus c, right? Now I'm going to exponentiate both sides. So this guy turns out to be y divided by 1 minus y equals e to the 2t times e to the c. But e to the c is a constant, so I name this one as a value of k, right? So I'm going to end up with k times e to the 2t, right? I'm going to use the initial condition right here. At t equals 0, 10% of the people heard the rumor, right? Which means 0.1 equals y, right? So I'm going to end up with 0.1 divided by 1 minus 0.1 equals k times e to the 2 times 0, right? So k equals 0.1 divided by 0.9. It's going to be 1 over 9, right? So we're going to substitute 1 over 9 for k back over here, right? So we're going to end up with y over 1 minus y equals 1 over 9 e to the 2t. Now we're going to cross multiply, so it could be 9y equals e to the 2t minus y times e to the 2t, right? So it's going to be 9 plus e to the 2t times y equals e to the 2t, right? I divide both sides by this guy, so y equals e to the 2t divided by 9 plus e to the 2t. This one is the final answer, right? Now let's move on to question C. At what time t is the rumor spreading the fastest? Alright, so we go back over here. The rumor spreading the fastest when y equals 1/2 right here, right? So we're going to substitute 1/2 of y into this guy right here to solve for t, right? So we have 1 over 2 over 1 minus 1 over 2 equals 1 over 9 times e to the 2t, right? So it's going to be 1 over 2 over 1 over 2 equals 1 over 9 times e to the 2t, right? So it could be e to the 2t. This guy equals 1, right? Multiply both sides by 9, it's going to be 9, right? Take natural log both sides, so it could be 2t equals ln 9, right? So t equals ln 9 divided by 2. But ln 9 is going to be ln 3 squared over 2. We can bring 2 to the front. So it could be 2 ln 3 over 2. It's going to be ln 3. This one is the final answer. Now let's move on to question 27. At time t greater than or equal to 0, the position of a particle moving along a curve in the xy plane st y of t, where ds over dt equals t minus 5 cosine t, and dy over dt equals 6 cosine 1 plus sine t. At time t equals 3, the particle is at position -1 and 2. Question A. Write an equation for the line tangent to the path of the particle at time t equals 3. Alright, so we need to find the slope m equals dy over ds, right? So it could be dy over dt divided by ds over dt, right? Dy over dt is right here. ds over dt is right here. And then you need to evaluate this expression at t equals 3, right here, right? So dy over ds evaluated as t equals 3. 6 cosine of 1 plus sine 3 over 3 minus 5 cosine 3, right? Press Ctrl Enter. It's going to be 0.314. This guy is x1, y1, right? So the equation of the tangent line is y equals the slope 0.314 times s minus s1, which means negative 1 right here, so it should be plus 1, right? Plus 2. Now question B. Find the time t when the line tangent to the path of the particle is vertical. Is the direction of the motion of the particle up or down at that moment? Alright, use the Christmas tree trick. The tangent line goes this way, the slope is positive. The tangent line goes this way, slope is negative. Tangent line is horizontal, slope is 0. Tangent line is vertical, slope is undefined. So we're going to go back over here. The slope is dy over ds. If the tangent line is vertical, the slope is undefined. The slope is undefined when ds over dt equals 0, right? Now ds over dt equals this one, right? So we have t minus 5 cosine t equals 0. Okay, s minus 5 times cosine of s, press enter. It's going to be right here. Now we need to find the 0 of this function, right? Remember t is greater than or equal to 0, right? So we only have one value of t right here, right? Press menu, number, set number 1. Go to the left, go to the right. The answer is 1.31. We're going to substitute 1.31 for t into dy over dt right here. Equals. We're going to print up the calculator. Press Ctrl Enter. It's going to be negative 2.311, which is less than 0, right? So the y coordinate is decreasing, right? And the particle is moving down at the moment. Question C. Find the y coordinate of the particle's position at t equals 0. We see that the particle at t equals 3 right here, right? So we're going to use the fundamental theorem of calculus, right? So we have y of 3 equals y of 0 plus the integral from 0 to 3 of y prime of t dt, right? So y of 0 equals, y of 0 equals 2 minus integral from 0 to 3 of 6 cosine of 1 plus sine t dt, right? So we're going to print up the calculator. We have 2 minus, hit the button right here and put the integral from 0 to 3 of 6 times cosine of, enter. It's going to be 3.633. Now question D. Find the total distance traveled by the particle for t between 0 and 3. So we have the distance equals the integral from 0 to 3 of square root of s prime of t altogether square plus y prime of t altogether square dt. Then press Ctrl Enter. It's going to be 13.453. Question 28. For t greater than or equal to 0, a particle is moving along a curve so that its position at time t is this guy. At time t equals 2, the particle is at position 1, 5. It's known that ds over dt is this guy, dy over dt is this guy. Question A. Is the horizontal movement of the particle to the left or to the right at t equals 2? So we need to calculate ds over dt, right? Because this is the horizontal movement at t equals 2, right? 2 right here. So we have, so it could be square root of 2 plus 2 over e to the second, right? So it could be 2 over e squared. This guy greater than 0. It tells us that the particle moves to the right at time t equals 2. Now we need to find the slope of the particle. So we have dy over ds equals dy over dt divided by ds over dt, right? So it's gonna be, and we need to evaluate this guy at t equals 2, right? It's gonna be the same thing as e squared sine square of 2 divided by 2, right? So we're gonna bring up the calculator. Press Ctrl Enter. It's gonna be 3.054. Now question B. Find the x-coordinate of the particle's position at t equals 4. Alright, so we're gonna use the fundamental theorem of calculus, right? We know that the initial position right here, t equals 2, we have s equals 1, right? So we have s4 equals s of 2 plus integral from 2 to 4 s prime of t dt, right? So we're gonna bring up the calculator. So we have 1 plus, hit the button right here, input the integral. Press Ctrl Enter. It's gonna be 1.252. C. Find the speed of the particle at time t equals 4. Find the acceleration vector of the particle at time t equals 4. Alright, so we know that the speed equals the square root of s prime of t altogether square plus y prime of t altogether square. Alright, so we're gonna bring up the calculator. Press Ctrl Enter. It's gonna be 0.574. Now find the acceleration vector of the particle at time t equals 4. We have a of 4 equals s double prime of 4, comma y double prime of 4. Probably we're gonna store the function at the beginning, right? But now it's not too late. So I name the function s prime of t as m of t. Press Ctrl and the button right here. You need to input s prime of t. Press Enter. Now I'm gonna name y prime of t as n of t. Press Ctrl and the button right here. Escape. Press Enter. Now I need to take derivative of each of this one and evaluate it at t equals 4, right? So I'm gonna press menu, calculus, derivative at the points right here. The variable is t, right? The value is 4. Press OK, right? So I just input m of t and then press Ctrl Enter. It's gonna be right here. Now I do exactly the same thing for n of t. Ctrl Enter. So it's gonna be negative 0.041 and 0.989. Now question D. Find the distance traveled by the particle from t equals 2 to t equals 4. So the distance equals the integral from 2 to 4 square root of s prime of t altogether square plus y prime of t altogether square dt, right? So we're gonna print up the calculator. So we just hit the button right here, input the integral from 2 to 4. Press square root sign, Enter. It's gonna be 0.650. Now let's move on to question 29. Let R be the function given by R of theta equals 3 theta sine theta for theta between 0 to 2 pi. The graph of R in polar coordinates consists of two loops, as shown in the figure above. Point P is on the graph of R, and the y-axis will be right here. Question A. Find the range of change of the x-coordinate with respect to theta at the point P. So it's the same thing as ds over d theta, where s equals r cosine theta, right? But r equals this one, so it could be 3 theta sine theta cosine theta, right? 3 theta over 2 sine 2 theta, right? Because we have sine 2s equals 2 sine s cosine s upon p, which means theta equals pi over 2, right? So evaluate this one as theta equals pi over 2. Now we're going to check derivative of this one. So we're going to print up the calculator. We're going to store the function first. Ask of theta. Press Ctrl the button right here. It's going to be 3 theta over 2. So hit the button right here, input the fraction. We have 3 theta over 2 times sine 2 theta. Press enter. Alright, press menu calculus. Derivative at a point. The variable is theta. The angle is pi over 2. Press OK. Now input S of theta. Press Ctrl enter. It's going to be negative 4.712. Now let's move on to question B. Find the error of the region between the inner and outer loops of the graph. Now, think about the unit circle. The y-axis represents the sine function. The x-axis represents the cosine function, right? Now, the radius is 3 theta sine theta, right? So the sine of the radius depending on the sine of sine theta, right? Vertical axis is the sine function, so anything above the axis right here is positive, right? And anything below the axis right here is negative, right? Now angle theta starts from here, which is 0, right? Travels counterclockwise direction, right? And it's going to be pi right here. So from 0 to pi, this one is the inner loop, right? The sine theta is positive, right? And then the radius is positive. Now, from pi to 2 pi right here, look at the domain right here. This guy is the outer loop, right? So then sine theta is negative. This implies the radius negative. So you know that if you plot the polar coordinate with the negative radius, you need to take the opposite side, right? So this guy go back over here. That's why you get the outer loop in the first and the second quadrant right here, right? The error is 1/2 the radius of the outer loop square, which means 3 theta sine theta all together square d theta, and the upper bound lower bound right here is pi to 2 pi. Subtract 1/2 of the integral from 0 to pi. 3 theta sine theta all together square d theta. Now we're going to print up the calculator. We need to store the function, right? So we're going to add calculate. Let's name the function as m of s. Hit the control the button right here. It's going to be 3s times sine s. Press enter. Alright, now hit the button right here, input the integral right here. Then press Ctrl enter. It's going to be 139.528. Now question C. The function r satisfies dr over dt equals 3 sine theta plus 3 theta cosine theta for theta between 0 to 2 pi. Find the value of angle theta that gives the point of the graph that is farthest from the origin. So, which means the maximum radius, right? So when it comes to maximum, minimum, we need to use the first derivative, right? And we have the closed interval right here, so we need to use the candidate test, right? Now we need to find the critical number by letting dr over d theta equals 0 is the same thing as 3 sine theta plus 3 theta cosine theta equals 0, right? So we're gonna print up the calculator, we're gonna grab this function and find the 0, right? So go to home screen, hit grab right here, escape, and press enter, escape right here. Now theta from 0 to 2 pi. So we need to restrict the domain, right? So go to menu number 1, right? Angle theta is from 0 to 2 pi. So we're going to press 2 times pi right here. Press OK. Right. Press menu number set number 1. Go to the left, go to the right of 0. 2.03, right? Menu number set number 1, go to the left, go to the right, 4.91, right? Now we need to create a table. Alright, we need to evaluate the R of theta, right? So bring up the calculator, go to the home screen, hit calculate. Now we need to store the function, right? Of theta, and then press Control, put it right here. Press enter. Alright, now we have R of 0. Escape 0, right? Absolute value of 0 escape 0, right? Remember, when we talk about the radius, it must be positive. So we need to take the absolute value of this guy. Second one, R of 2.03. Right? Press Control, enter. Escape 5.459. Take absolute value of this one, escape 5.459, right? The third one, R of 4.91. Press Control, enter. Escape negative 14.443. Take absolute value of this one, it could be 14.443. And the last one, 2 pi, substitute over here. Sine 2 pi equals 0, right? So this guy 0, 0 over here. Now, this one is the maximum value at theta equals 4.91. So we need to say that the value of angle theta equals 4.91. gives the point on the graph that is farthest from the origin. Now let's move on to question 30. The graphs of the polar curve r equals 2, which is the circle, right? And r equals 3 plus 2 cosine theta, which is the limation, right? So the limation is right here. And the circle is right here. As shown in the figure above, the curves intersect at theta equals 2 pi over 3. So this one is 2 pi over 3. And 4 pi over 3 is right here. Question A. Let R be the region that is inside the graph of the circle R equal 2 and also inside the graph of the limation as shaded in the figure above. Find the area of R. Alright, so we need to separate this guy into two regions. And then, when you calculate the area of this one, you need to multiply by 2 because it's going to be symmetric about the polar axis right here. Right? So, basically, the area is the interval from 0 to 2 pi over 3. The purple one right here bounded by the circle, right? The circle has the equation r equal 2, right? So we have 2 square d theta, right? Plus the area of the 0, 1 right here, right? It's going to be from 2 pi over 3 to pi right here, right? this guy bounded by the limit zone, right? So we have 3 plus 2 cosine theta altogether square d theta, right? And then whatever you got right here, you need to multiply by 2 to get the whole thing right here. So we're gonna print up the calculator. It's gonna be 10.37, right? Now question B. A particle moving with non-zero velocities along the polar curve r equals 3 plus 2 cosine theta has position s of t, y of t at time t with theta equals 0 when t equals 0. This particle moves along the curve so that dr over dt equals dr over d theta. Find the value of dr over dt as theta equals pi over 3 and interpret your answer in terms of the motion of the particle. We're going to use this guy right here. dr over dt evaluated at theta equals pi over 3. This guy actually equals this guy, right? dr over d theta evaluated at theta equals pi over 3, right? So the function r is right here, right? So we're gonna print up the calculator. We need to store the function ask. Press enter. Alright, now press menu calculus derivative at the point right here, variable ask. The value is pi over 3. So press pi divided by 3. Press OK. Input the function r of ask. Press Ctrl Enter. It's going to be negative 1.732. This guy less than 0. It tells us that the radius is increasing, right? Then the particle is moving closer to the origin. Also, the radius is positive when theta equals pi over 3. Question C. For the particle described in part B, dy over dt equals dy over d theta. Find the values of dy over dt at theta equals pi over 3 and interpret your answer in terms of the motion of the particle. Alright, so we're going to do exactly the same thing, right? So we know that y equals r sine theta, right? But r equals 3 plus 2 cosine theta, so it could be 3 plus 2 cosine theta times sine theta, right? Now we need to calculate dy over dt at theta equals pi over 3 equals dy over d theta at theta equals pi over 3, right? So we're gonna store the function and we're gonna calculate the derivative of this one, right? Press enter. Now press menu calculus number 2. The variable is ask, the values is pi over 3. Press OK. Input y of ask, enter. It's going to be 0.5. This guy is greater than 0. The value of the y function right here is increasing, right? So look at the s and y coordinate right here. This is y, this is s, right? If this guy increasing, it's gonna move away from the x-axis, right? Question 31. For time t greater than or equal to 0 seconds, the position of an object traveling along a curve in the xy plane is given by the parametric equations s of t, y of t, where the s over dt equal this guy and dy over dt equal this guy. Describe the behavior of the part of the particle as t increases without bound. Alright, so we need to find the limit, right? So basically, we have limit of ds over dt when t approaches infinity. It's going to be limit of 2 over t minus 8 power 1/3 when t approaches infinity. Alright, so when t approaches infinity, this guy approaches 0, right? So we only have negative 8 power 1/3, right? It's going to be negative 2. Now, limit of dy over dt when t approaches infinity is going to be limit of e to the negative 3t when t approaches infinity, and it's going to be limit of 1 over e to the 3t when t approaches infinity is going to be 0, right? We need to find the limit of dy over ds when t approaches infinity, right? Which means the slope of the path, right? Limit when t approaches infinity of dy over dt divided by ds over dt, and it's going to be limit when t approaches infinity of e to the negative 3t divided by 2 over t minus 8 altogether 1/3, right? It's going to be 0 over negative 2 is going to be 0, right? Now observe that the limit of the horizontal velocity is negative 2, which is less than 0. It tells us that the particle continues to move to the left at a constant speed of 2 units per second, right? Now for the vertical motion, the vertical motion stops as the vertical velocity approaches 0, right? Right here. So finally, we're going to come into conclusion. The path of the particle approaches a horizontal line since the slope dy over ds approaches 0 when t approaches infinity, right? Now let's move on to question 23. Give a value of p such that this series converges, but this series diverges. Alright, so we're going to start with this guy. This guy actually the p series, right? So in order for the p series diverges, this guy right here, 2p must be less than equal to 1, or p less than equal to 1/2, right? Now this one is the alternating series, right? So we're going to use the alternating series test to determine the value of p so that the series converges, right? So observe that p must be greater than 0 so that the limit of 1 over n to the p when n approaches infinity equals 0, and the series 1 over n raised to the p decreasing, right? So by alternating series test, the series converges, right? So we're going to combine this guy and this guy. The answer must be p greater than 0, less than equal to 1/2, right? So here's how you show your work on the AP exam. Now let's move on to question D. Give a value of p such that this series diverges, this series converges. Alright, so observe that this guy is the p series. This guy also a p series, right? So the p series converges when 2p greater than 1, right? Then p greater than 1/2, right? The series diverges when p less than equal to 1, right? We're going to combine these two guys. So 1/2 less than p less than equal to 1. This one is the final answer. Now let's move on to question 24. The function f is defined by a power series for all real numbers s for which the series converges. Question A. Determine the interval of convergence of the power series for the function f. Now we're going to use the ratio test. The series converges when limit of this guy less than 1. Diverges when limit of this guy greater than 1. So keep that in mind. Alright, so we have limit of this guy right here. We're gonna let this guy right here be a sub n, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit absolute value of a sub n plus 1, which means s minus 2 raised to the n plus 1 over 3 raised to the n plus 1 times n plus 2, right? Divide by a sub n, which means you're going to multiply by its reciprocal, right? So it could be 3 raised to the n times n plus 1 over s minus 2 raised to the n. Limit when n approaches infinity. Now this guy cancel out. We have s minus 2 left on the top, right? This guy cancel out. We have 3 on the bottom, right? Now we have n plus 1 on the top left, right? And n plus 2 on the bottom. Now s minus 2 is not related to this one. I'm going to print this one outside. Don't forget absolute value sign. Limit of n plus 1 over 3 times n plus 2, right? So it's going to be absolute value of s minus 2. When n approaches infinity, this guy right here approaches 1/3, right? So I put 1/3 right here, right? Now, in order for this series to be convergent, we need this guy less than 1, right? Now, I'm going to multiply both sides by 3. So it could be absolute value of s minus 2 less than 3, right? So it's going to be negative 3 less than s minus 2 less than 3, right? And then I'm going to add 2 3 sides. So it's going to be negative 1 less than s less than 5. Now, don't forget to check the endpoints. Negative 1 and 5. Now, s equals negative 1. We substitute negative 1 for s into this guy right here, right? So we have, and it's going to be the series n go from 1 to infinity. Negative 3 raised to the n can be written as 3 raised to the n times negative 1 raised to the n over 3 raised to the n times n plus 1, right? This guy and this guy cancel out, so it could be the series n go from 1 to infinity of negative 1 raised to the n over n plus 1. And this guy actually the alternating harmonic series, which is convergent conditionally. Now I'm going to check s equals 5, right? So the series becomes n goes from 1 to infinity. Substitute 5 for s, so it could be 5 minus 2, it could be 3. 3 raised to the n over 3 raised to the n times n plus 1, right? Now I'm going to simplify this guy and this guy, so it turns out to be, now I can rewrite this one as the series n start from 0 to infinity, right? And this guy becomes 1 over n, right? And this guy actually harmonic series, right? Harmonic series diverges, right? So the final answer should be this inequality right here. And you need to include s equal negative 1, right? Because this one converges, right? So the final answer must be negative 1 less than or equal to s less than 5. Question C. Use the first 3 non-zero terms of the power series for the function f to approximate f of 1. Use the alternating series error bound to show that this approximation differs from f of 1 by less than 1 over 100. The first 3 terms are right here. I'm going to copy them down. So you have f of 1. Substitute 1 for s over here. So if you simplify this one, it's actually 47 over 54. Now, next one, we need to use the alternating series error bound to show that this approximation differs from f of 1 by less than 1 over 100. You know that the power series for the function f evaluated at s equal 1 is an alternating series whose terms decreasing in absolute value to 0. The alternating series error bound is the absolute value of the 4 term, right? Because this one is the 3 non-zero terms. So absolute value of f of 1 minus 47 over 54 less than the value of the 4 terms, which is, but s equals 1 right here, right? So I can remove s right here. I'm going to put 1 there. 1 over 108. And this guy actually less than 1 over 100, right? Now let's move on to question 25. The function g has derivatives for all orders. And the Maclaurin series for the function g is given by the alternating series. Using the ratio test, determine the interval of conversion of the Maclaurin series for the function g. So this question is similar to the question 24, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit when n approaches infinity absolute value of -1 raised to the n plus 1 times s raised to the 2 parentheses, be careful, n plus 1 right here and then plus 1 outside over 2 parentheses n plus 1 plus 3 outside, and then divide by a sub n, which means multiply by its reciprocal, right? So it could be 2n plus 3 over -1 raised to the n times s raised to the 2n plus 1. I'm going to simplify this guy. It's actually limit when n approaches infinity. -1 raised to the n and -1 raised to the n right here cancel out, and you have -1 left. When you check absolute value, it's going to be positive, right? So this guy right here completely gone, right? Now the top right here becomes absolute value of s. Distribute this one, it could be s raised to the 2n plus 3, right? Times 2n plus 3 over this guy actually 2n plus 5, right? Times this guy s raised to the 2n plus 1, right? Now this guy actually s raised to the 2n plus 1 times s squared, right? So this guy and this guy cancel out, right? So we have limit when n approaches infinity, right? Of absolute value of s squared times 2n plus 3 over 2n plus 5, right? So when n approaches infinity, this guy right here approaches 1, right? So we only have s squared left, right? In order for this guy to be convergent, this guy must be less than 1 by the ratio test, right? So it turns out to be -1 less than s less than 1. You're not gonna stop right here, right? Be careful. You need to check the endpoints. So you need to check s equals -1 and s equals 1, right? S equals -1, right? Substitute -1 for s into this series. So we have the series n start from 0 to infinity of -1 raised to the n. -1 raised to the 2n plus 1 is still -1 because this is odd power, right? Over 2n plus 3. So this guy turns out to be the series n start from 0 to infinity. -1 raised to the n and -1, it becomes -1 raised to the n plus 1, right? Times 1 over 2n plus 3, right? This one is the alternating series, right? So we need to use the alternating series test to determine if this one is convergent, right? So we're gonna let a sub n be 1 over 2n plus 3, right? Now we need to find the limit of a sub n. When n approaches infinity, it's gonna be limit of 1 over 2n plus 3 when n approaches infinity and it's actually 0, right? The sequence a sub n right here is decreasing because when n getting bigger, a sub n getting smaller, right? So from these two guys, we can conclude that the series converges by the alternating series test. Now for s equals 1, we do exactly the same thing, right? So the series becomes -1 raised to the n times 1 over 2n plus 3, right? And you're going to do exactly the same thing as you did on the top, right? I'm going to leave this one for you to practice, right? So you can conclude that the series converges by alternating series test, right? So finally, you have s equals 1 and s equals -1 combined with this guy. So the answer should be -1 less than equal to s less than equal to 1. Now let's move on to question B. The Maclaurin series for G evaluated at s equals 1/2 is an alternating series whose terms decrease in absolute value to 0. The approximation for G of 1/2 using the first two non-zero terms of this series is 17 over 120. Show that this approximation differs from G of 1 over 2 by less than 1 over 200. Alright, this question very simple, right? Easier than the question 24C, right? So you have absolute value of G of 1 over 2. Subtract 17 over 120 should be less than the third term, right? Because this one is first two non-zero term. So the third term is right here, right? S to the fifth over 7. But s equals 1/2, right? So I have 1 over 2 to the fifth over 7, right? So it can be 1 over 32 over 7, right? It turns out to be 1 over 224, which is less than 1 over 200, right? Question 14. Let H be a function having derivatives of all orders for s greater than 0. Select the values for the function h and its first four derivatives are indicated in the table above. The function h and these four derivatives are increasing on the interval 1 to 3. Question A. Write the first degree Taylor polynomial for the function h about s equals 2 and use it to approximate h of 1.9. Is this approximation greater than or less than h of 1.9? Alright, first we have the Taylor polynomial expansion for the function h is given by the formula where c is the center, so c equals 2 right here. Now we only need the first degree Taylor polynomial, right? So we have T1 of s equals h of c, which means h of 2 plus h prime of 2 times s minus 2. We stop right here, right? No, this is the first degree. Now we substitute values. H of 2 is 80 right here. Plus h prime of 2 is 128 right here. Times s minus 2, right? Now we need to calculate T1 of 1.9, right? So it's going to be 80 plus 128 times 1.9 subtract 2, it could be negative 0.1, right? Now if you use a calculator, this guy actually 67.2. We need to compare this guy right here with this guy. Since the second derivative of the function h of s is greater than 0 and increasing for s between 1 and 3, the function is concave up. So the tangent line is below the graph, right? It could be like this, then the line is right here. Therefore, T1 of 1.9 less than H of 1.9, right? So the approximation is less than the actual value. Now let's move on to question B. Write the third degree Taylor polynomial for the function h about s equal 2 and use it to approximate h of 1.9. Alright, so we're gonna go back to this formula right here. The third degree Taylor polynomial, we're gonna stop right here. Right? Now we need to use the value of this guy, this guy, this guy, and this guy from the table right here. Right? And then we're going to simplify it, right? So we have, now we need to calculate T3 of 1.9, right? So substitute 1.9 for S and use the calculator. The answer should be approximately. Question C. Use the Lagrange error bound to show that the third degree Taylor polynomial for the function h about s equal 2 approximates h of 1.9 with an error less than 3 times 10 to the negative 4. Now remember, the remainder for a third degree Taylor polynomial is for some z between 1.9 and 2 right here. This is c, right? This one is s, and z is between c and s, right? So maximum of this one when z equals 2 right here, because 2 greater than 1.9, right? So we have absolute value of the fourth derivative of h at 2 over 4 factorial, it could be 24, right? Times s minus 2, right? Now, the fourth derivative of h at s equal 2 is given right here. 584 over 9, right? So it's going to be 584 over 9 divided by 24, right? Times s right here equals 1.9, subtract 2, it could be negative 0.1, right? So when you raise to the 4, it's going to be positive, right? So I don't need to put this guy inside the absolute value sign anymore, right? Now you're going to print up the calculator. Hit the button right here, input the fraction. Press Ctrl, Enter. It's going to be 0.00027, right? It's the same thing as 2.7 times 10 to the negative 4, right? And this guy actually less than 3 times 10 to the negative 4, right? Now let's move on to question 15. Let f be the function given by fs equals e to the negative s squared. Write the first 4 non-zero terms and the general terms of the Taylor series for the function f about s equals 0. So the center equals 0, and then this guy becomes Markov series, right? And you know that e to the s equals, now you need to substitute negative s squared for s right here. So we have e to the negative s squared equals, and we need the general term, right? So plus etc. plus the general terms right here. So it could be negative s squared all together raised to the n over n factorial, right? Now we're going to simplify this one, so it could be, now we can use the general term right here to represent the function fs right here. So this guy actually the sum when n starts from 0 to infinity of negative 1 raised to the n s raised to the 2n over n factorial, right? Now let's move on to question B. Use your answer from part A to find the limit of this one, right? So we have 1 minus s squared subtract f of s. It's actually 1 minus s squared subtract the whole thing right here, right? So I just copy this one down. Now I'm going to distribute -1 and I'm going to simplify. So it turns out to be, now I'm going to divide by s to the 4, right? So if I take this one divided by s to the 4, it's going to be this guy divided by s to the 4, and the same thing as this guy divided by s to the 4, right? So I'm going to end up with -1/2 plus s squared over 6 subtract etc, right? Now I need to take the limit of this one, so I have limit of 1 minus s squared minus f of s over s to the 4 when s approaches 0. It's going to be limit of -1 over 2 plus subtract etc, right? When s approaches 0, this guy approaches 0, the answer is -1 over 2. Now let's move on to question C. Write the first 4 non-zero terms of the Taylor series for this integral. Use the first 2 terms of your answer to estimate this guy. Integral from 0 to s of e to the negative t squared dt is integral from 0 to s. Now we're going to use Taylor polynomial expansion for this guy, which we did in question A, right? So it's actually antiderivative of 1 is going to be t, right? This guy actually t cubed over 3 plus t to the 5th over 10 minus t to the 7th over 42 plus etc. Evaluated from 0 to s. So it's going to be s minus s cubed over 3 plus s to the 5th over 10 minus s to the 7th over 42, right? So the first 2 terms right here. So the integral from 0 to 1 over 2 e to the negative t squared dt is actually s equals 1/2, right? So it's going to be 1/2 subtract 1/2 cubed divided by 3, right? So it's going to be 1 over 2 minus 1 over 24, right? So it's going to be 11 over 24, right? Now let's move on to question D. Explain why the estimate found in part C differs from the actual value of this guy by less than 1 over 200, right? So we have the absolute value of the integral from 0 to 1 over 2 e to the negative t squared dt subtract this guy right here 11 over 24, always less than the third omitted terms, which is this guy right here, right? But s equals 1 over 2, right? So we have 1/2 to the 5th over 10, right? Now we're going to simplify. It's going to be 1 over 320, right? And this guy actually less than 1 over 200, right? Since this guy right here is an alternating series with individual terms that decrease in absolute value to 0, right? Now let's move on to question 16. Let f be a function with derivatives of all orders, and for which f of 2 equals 7. When n is odd, the n-derivative of the function f at s equals 2 is 0. When n is even and n greater than or equal to 2, the n-derivative at s equals 2 is given by this formula. Question A. Write the 6-degree Taylor polynomial for the function f about s equal 2. So the Taylor polynomial expansion is given by the formula. Now we have p set of s equals. Now when n is odd, the n derivative of the function f at s equal to is 0, right? So n is odd right here, n is equal 1 for this one, right? The first derivative. This is the third derivative, right? N equals 3. This is n equals 5, right? And derivative equals 0, right? So we only care about the first one right here. It's going to be f of 2, right? The center s equals 2. So a equals 2. F of a is going to be f of 2. This guy right here equals 0, right? Now this guy right here, n equals 2. We're going to use the formula right here, right? So we have f double prime of 2 over 2 factorial, right? Times s minus 2 square, right? N equal 3, it's going to be 0. N equal 4, it's going to be plus the 6 derivative, right? Now we substitute value f of 2 equals 7 right here. Plus f the program, we're going to use the formula right here, right? So n equal 2, substitute over here, so we have 1 factorial over 3 square, right? Times 1 over 2 times s minus 2 square plus n equals 4, substitute over here, so we have 3 factorial over 3 to the 4 times 1 over 4 factorial times s minus 2 to the 4 plus n equals 6, it's going to be 5 factorial over 3 to the 6 times 1 over 6 factorial times s minus 2 to the 6. Now question B. In the Taylor series for the function f about s equal 2, which is a equal to, what is the coefficient of s minus 2 to the 2n for n greater than or equal to 1? Now observe that this guy right here, this guy right here, and this guy right here, they are the same, right? If I generalize this one, it's actually 2n derivative of the function f at s equal a over 2n factorial, right? Times s minus a raised to the 2n. Now the coefficient is this guy right here, right? Look, they ask you to find the coefficient. So we have, now in order to find this one, we look at the formula right here. If this guy n, this guy n, and this guy n, now we have 2n right here, so we just replace n with 2n, right? So we have, now we're going to simplify this one, 2n minus 1 factorial, rewrite this one, over 2n factorial can be written as 2n minus 1 factorial times 2n, right? Times 1 over 3 raised to the 2n, right? So this guy and this guy cancel out. We have 1 over 2n times 3 raised to the 2n. This one is the final answer. Now let's move on to question C. Find the interval of convergence of the Taylor series for f about s equal 2. Alright, so we're going to go back over here. The Taylor series is right here, right? This one is the first 6 terms, right? You know that the first term right here is going to be 7, right? And you look at the second term right here, you have the pattern right here. And this pattern actually right here, right? So we have, now in order to find the interval of convergence, we're going to use ratio test, right? So we have limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. It's going to be limit when n approaches infinity of, I'm going to let this guy right here be a sub n, right? So we have a sub n plus 1 is going to be, we need to multiply by this one reciprocal, right? So it's going to be limit when n approaches infinity, absolute value of, we have 2n on the top right here, so we have 2n right here over 2 times n plus 1 on the bottom. Now this guy right here actually 3 raised to the 2n times 3 square, right? So this guy and this guy cancel out. We have 3 square on the bottom, which is 9, right? And this guy right here actually 2n plus 2. So we can rewrite this one as minus 2 raised to the 2n times s minus 2 square. This guy cancel out. So we have s minus 2 square, right? Now we're going to simplify 2 and 2, right? So this guy turns out to be, we're going to use the relative growth rate, right? So n grows faster than 1. So it's going to be absolute value of s minus 2 square over 9. Limit absolute value of n over n when n approaches infinity. And this guy actually 1, right? So we have s minus 2 square over 9, right? And this guy always positive, so I can remove the absolute value side, right? I don't have enough space, so I'm going to write over here. So it could be s minus 2 altogether square over 9 less than 1, right? So it could be s minus 2 altogether square less than 9. Take square root both sides, so it could be absolute value of s minus 2 less than 3, right? So it's going to be negative 3 less than s minus 2 less than 3, right? Add 2 3 sides, so we have negative 1 less than s less than 5, right? Now we need to check for the endpoints, right? So the first one s equal negative 1 and the second one s equal 5. S equal negative 1. Substitute negative 1 for s over here. So we have, so it's going to be 7 plus this guy cancel out, right? I'm going to bring 1/2 to the front, so it could be 1/2 series 1 over n when n start from 1 to infinity, right? Now since this one is the harmonic series, it's always divergent, right? So if this one diverges, the whole thing right here diverges, right? Alright, substitute 5 for s over here. So we have, if you simplify this guy, it's actually 7 plus the series 1 over 2n when n start from 1 to infinity. So this guy actually, the first case, right, it still diverges, right? If you rewrite this one as 1 plus 1 over 2 series n start from 1 to infinity 1 over n. This one is harmonic series, so this could be divergent, right? So if this one divergent, the whole thing divergence, right? So your final answer must be negative 1 less than s less than 5. Now let's move on to question 17. The Maclaurin series for the function f is given by this guy. And converges to FOS for absolute value of s less than r, where r is the radius of convergence of the Maclaurin series. Question A. Use the ratio test to find r. Alright, so we have limit absolute value of a sub n plus 1 over a sub n when n approaches infinity equals limit. Right, let this one be a sub n. So we have a sub n plus 1 is going to be negative 3 raised to the n, right, over n plus 1, right, times s raised to the n plus 1. Divide by a sub n, we're going to multiply by its reciprocal, right? So it could be, now we're going to simplify this. The bottom right here can be written as negative 3 raised to the n times negative 3 power of negative 1, right? So this guy and this guy cancel out, right? So negative 3 power of negative 1, I'm going to bring it to the top. It turns out to be negative 3 power of 1, so it could be negative 3, right? n over n plus 1 right here. Now this guy right here can be written as s to the n times s. This guy cancel out, right? So I only have s left right here, right? So it's gonna be absolute value of 3s, right? And in order for this series to be convergent, this guy must be less than 1 by the ratio test, right? 3 times absolute value of s less than 1. So it's gonna be absolute value of s less than 1 over 3. Now we look at this one right here, absolute value of s less than r. This guy absolute value of s less than 1/3. So we're gonna match this guy. So the radius of convergence is 1 over 3. Now let's move on to question B. Write the first four non-zero terms of the Maclaurin series for f', the derivative of f. Now this one is the function f of s, right? So we just write the first four terms of the function f of s first, and then we're gonna take derivative, right? So now we're gonna take derivative of this one. It's gonna be 1 minus 3s, right? Plus 9s squared, right? Bring 4 to the front, so it could be cancel out right here. Minus 27s cubed, right? Now this guy actually geometric series where the common ratio equals negative 3s, right? Because every single time you're gonna multiply by negative 3s to get the net terms, right? So we have f prime of s equals the series k start from 0 to infinity of negative 3s raised to the k. And this series converges because we have this guy right here, absolute value of s less than 1 over 3, right? This guy actually absolute value of 3s less than 1. And this guy actually absolute value of common ratio less than 1, or absolute value of negative 3s less than 1. So by geometric series, the series convergent to a sub 1 over 1 minus r. It's going to be a sub 1 right here, 1 over 1 minus negative 3s, right? So it could be 1 over 1 plus 3s, and this guy actually the rational function, right? Let's move on to the last question. Write the first four non-zero terms of the Maclaurin series for e to the s. Alright, so we have e to the s equals 1 plus s squared over 2 factorial plus s cubed over 3 factorial, right? And this one is the first four non-zero terms, right? Now we're going to simplify this one. It's going to be 1 plus s squared over 2 plus s cubed over 6, right? Now use the Maclaurin series for e to the s to write the third degree Taylor polynomial for g of s equals e to the s times f of s about s equals 0. So we have g of s equals e to the s, which means 1 plus s squared over 2 plus s cubed over 6 plus etc. times f of s, which means s minus 3 over 2 s squared plus 3s cubed subtract etc. Right? So we just multiply this one out, right? So 1 times s is going to be s, right? 1 times negative 3 over 2 s squared is going to be negative 3 over 2 s squared. 1 times 3s cubed is going to be plus 3s cubed, right? S times s is going to be s squared, right? S times this one is going to be negative 3 over 2s cubed. S times this one is going to be plus 3s to the 4, right? And s squared over 2 times this one is going to be plus s cubed over 2. S squared over 2 times this one is going to be negative 3 over 4 s to the 4. And this guy times this guy is going to be 3 over 2 s to the 5th, right? S cubed times this one, it could be s to the 4. But we only need the third degree, right? So we can stop right here, right? Now we're going to simplify. S minus 3 over 2 s squared plus s squared. It's going to be negative 1 over 2 s squared, right? And 3s cubed minus 3 over 2 s cubed. It's going to be 3 over 2 s cubed plus 1 over 2 s cubed. It's going to be 2s cubed, right? This guy, s to the 4, we can ignore, right? Because we only need third degree, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.